we are going to discuss the Laplace transform formulas. So we have learned about the Laplace transform concept. So now we are going to discuss the Laplace transform formulas. These formulas are very, very important while solving the questions. So please please listen carefully. Okay. For f of t, what is the Laplace transform? F of s is equal to integration of t is equal to minus m to plus m t, f of t into e to the power of minus st into dt. And what is the ROC? ROC is nothing but the real part of s. Only for a particular range of sigma only it is going to get defined. So listen carefully. Only for some particular range of sigma, only for some particular range of sigma only we can say that the Laplace transform is going to get well defined. So whatever this Laplace transform, it is going to define only for some particular range of sigma. That is called as the ROC. So we can say for f of t was the Laplace transform, f of s is equal to integration of t is equal to minus m to plus m t f of t into e to the power of minus st into dt. So this Laplace transform is going to define only for some particular range of sigma. It is called as the ROC. So ROC is nothing but real part of s. So now for delta of t, what is the Laplace transform? It is 1. Fourier transform is also 1 and the Laplace transform is also 1. So for delta of t, the Laplace transform is 1 and the ROC is nothing but the real part of s, which is all over the plane. So you take any value of sigma, it is defined. For any value of sigma, it is going to get defined. So therefore we can say that the delta of t, the Laplace transform is 1 and the ROC is nothing but the real part of s, which is all over the s plane. So you take any value of sigma, this is well defined. So this is the ROC. So for delta of t, the Laplace transform is 1 and ROC is nothing but which is the real part of s, which is all over the s plane. Means it is defined for each and every value of the sigma which is present in the s plane. And for v of t, the Laplace transform is 1 by s, and it is defined only for sigma greater than 0, and it is defined only for sigma which is greater than 0. So listen carefully. For u of t, the Laplace transform is 1 by s, and it is defined for only for sigma greater than 0, which is nothing but ROC. ROC is nothing but real part of s, which is sigma greater than 0. So we can say for u of t, the Laplace transform is 1 by s, and ROC is nothing but sigma greater than 0. And for u of minus t, I can say that the Laplace transform is minus 1 by s, and the ROC is sigma less than 0. So listen carefully. For u of minus t, the Laplace transform is minus 1 by s, and the ROC is sigma less than 0. Means for only sigma less than 0, this function is going to get defined. This Laplace transform is going to get defined for this function. Similarly, you multiply minus on both sides, then what you are going to get? Minus of u of minus t as the Laplace transform, which is equal to 1 by s. Same ROC is same as the previous case, just we are multiplying minus on both sides. So therefore we can say the ROC is nothing but which is sigma less than 0. So this one always you have to keep in your mind. Therefore listen carefully. For u of t, the Laplace transform is 1 by s, and the ROC is sigma greater than 0. And for u of minus t, the Laplace transform is minus 1 by s, and the ROC is sigma less than 0. Just multiply on both sides, we are going to get minus of u of minus t as the Laplace transform 1 by s, and the ROC is nothing but which is sigma less than 0. ROC is nothing but sigma less than 0. So now, if you remember these things, then the remaining things are going to get simple. So for e to the power of minus at into f of t, what is the Laplace transform? F of s plus a, because for f of t, the Laplace transform is f of s, then for e to the power of minus at into f of t as a Laplace transform f of s plus a is replaced s by s plus a, and the ROC is nothing but which is the real part of s plus a. It is nothing but suppose in the previous case the ROC is sigma, and now it will become sigma plus a. That's it. See, for f of t, the Laplace transform is f of s, and the ROC is sigma. Then for e to the power of minus at into f of t, the Laplace transform is f of s plus a minus v plus s by s plus a, and the ROC is which is sigma plus a. Sigma plus a, real part of s plus a is nothing but sigma plus a, we can call it. Because yeah, suppose a is a complex number, then you have to take only the real part of that one, real part of them. That is the reason I have taken the real part of s plus a. The real part of s and real part of a is to the addition, and we are going to get the overall real part of this one. For e to the power of et into f of t, the Laplace transform is f of s minus a is replaces by s minus a. Here the ROC is real part of s minus a. So what is the general equation I can write from these two things? The general equation I can write like this, which is basically here, carefully. So let me write here. The general expression, let me write here, which is nothing but e to the power of plus or minus at into f of t as the Laplace transform. F of here minus means here plus means here minus, opposite. So yes, minus plus a. And what is the ROC? ROC is nothing but the real part of same as it is, s minus plus a. So therefore you can say that this is the ROC, right? So therefore here plus means here minus, here plus means here minus, same as it is minus. Here minus means here plus, here also plus. So this is a thing always you have to keep in your mind. So therefore I can say for e to the power of plus or minus at f of t, what is the Laplace transform? F of s minus plus a, plus means here minus, here minus means here plus, and the ROC is also real part of s. So this is a thing you have to keep in your mind. So for f of t, so let me write here. So let me write here. So f of t as the Laplace transform f of s is having a ROC, real part of s. So same thing, right? So these things always you have to keep in your mind. So like this always you have to keep in your mind. So here I have written the same thing I have written here. So like this you have to keep in your mind. So now let me keep this one here star mark so that you can easily able to understand. So what is the one more formula? So what is the one more formula? I have already told you. So see, let me write from starting onwards so that you can easily able to understand. So let me write from starting onwards. Please bear with me for some time so that you can get the sequence. I am going to write only the important formulas. I will not write each and everything. I will write only the important things which are need to be remembered for the examinations. I will not write each and everything. I will write only the important stuff only. I will write what we have learned. So what is the first thing that we have learned? The first thing that we have learned is for delta of t. So here, so let me wait a minute. It is not responding. So give me around 30 seconds so that we can able to make this one very clearly. I hope it is not responding. So wait for more 10 seconds so that things are going to get very simplified. Okay, now everything is fine. So now listen carefully. So for delta of t, what is the Laplace transform? The Laplace transform is 1. And what is the ROC? ROC is nothing but sigma. ROC is nothing but the real part of this. The real part of this, which is all s plane. And what is the second thing we have learned? Second thing that we have learned is for u of t. For u of t, what is the Laplace transform? The Laplace transform is 1 by s. And what is the ROC? The ROC is nothing but the real part of s, which is greater than 0. And similarly, for u of minus t, so for u of minus t, what is the Laplace transform? It is minus 1 by s. And the real part of s is less than 0. And if you multiply it on both sides, then we are going to get minus of u of minus t. It is having a Laplace transform 1 by s. And ROC is same. The real part of s is less than 0. Then I have already told you a general formula. E to the power of minus plus at into f of t. So here, let me write here f of t. So let me run this part. So let me f of t. So let me run this part. So let me run this part. So therefore, for f of t, the Laplace transform is f of s. which is having a ROC real part of S. Real part of S. Therefore, e to the power of minus plus at f of t as the Laplace transform f of s plus minus a. So there minus means plus a plus means minus a. And the ROC is real part of s plus or minus a. Whatever the condition is same as it is. So these things always you have to keep in your mind. Until up to this only we have studied, right? So now, what is the next thing? So now we are going to apply this formula or this concept. Here f of t is u of t, e to the power of minus at into u of t. So you know u of t is the Laplace transform is 1 by s. So in place of s substitute s plus a. So you are going to get 1 by s plus a. There for u of t, the Laplace transform is 1 by s and ROC is real part of s is greater than 0. So now in place of s substitute s plus a. So real part of s plus a greater than 0. The real part of s plus a greater than 0. So real part of, suppose a is also real number, then sigma plus a greater than 0. Suppose a is also real number, some real number, then what you are going to get sigma plus a greater than 0. So sigma greater than minus a. A can be either positive, a can be either negative. It can be anything, right? So this is what we can see here. So therefore, this is the thing we have applied. So now minus of e to the power of minus at into u of minus t. So what is the meaning of this one? So what is the meaning of this one? So you know here f of t is nothing but minus of u of minus t. So f of t is nothing but minus of u of minus t. What is the Laplace transform? 1 by s. And the ROC is real part of s less than 0. So here we are going to multiply e to the power of minus at. So here is we have to replace s by s plus a. So 1 by s plus a. And the ROC is real part of s plus a less than 0. Here a is also real number. So therefore, the real part of s is nothing but sigma. So sigma plus a less than 0. So therefore, sigma less than minus a. Here a can be positive or a can be negative. So now, the next thing is e to the power of at into u of t. Here e to the power of minus at into u of t. Here e to the power of at into u of t. So for u of t, you know what is the Laplace transform 1 by s. Here e to the power of at you are multiplying. So replace s by s minus a. 1 by s minus a. For u of t, you know the ROC, the real part of s is greater than 0. So here replace s by s minus a. The real part of s minus a greater than 0. Here a is also real number. So the real part of s is sigma. So sigma minus a greater than 0. So sigma greater than a. A can be either positive or a can be negative. So this is the application of the concepts that we have learned. So I won't no need to further explain. So now minus e to the power of at into u of minus t. I already told you what is f of t here. F of t is equal to minus of u of minus t. Minus of u of minus t. What is the Laplace transform 1 by s? Here we are multiplying e to the power of at. So we plus s by s minus a. So we are going to get 1 by s minus a. And you know for minus of u of minus t, what is the ROC? Real part of s less than 0. So replace s by s minus a. So real part of s minus a less than 0. So here a is a real number. So s real number is sigma. Sigma minus a less than 0. So sigma less than a. A can be either positive or a can be either negative. So now the next thing is, so until here you have to keep in your mind. So now the next thing is here. Suppose f1 of t. So f1 of t. So let me write this form. See here f1 of t as a Laplace transform f1 of s with an ROC1, and f2 of t as a Laplace transform f2 of s which have an ROC2. Suppose if you are doing a linear combination of these two functions, so you are going to get the net function which is nothing but a1 into f1 of t plus a2 into f2 of t, which has the Laplace transform a1 into f1 of s plus a2 into f2 of s. And the ROC is nothing but intersection of the two ROCs, means the common range of ROC. The common range of ROC. So let me write the formula here so that you can easily able to understand. So here listen carefully. Suppose if f1 of t has the Laplace transform f1 of s, which is having an ROC1. Suppose f2 of t is having a Laplace transform f2 of s, which is having an ROC2. Suppose if you are taking a linear combination a1 into f1 of t plus a2 into f2 of t. So for this one, what is the Laplace transform, which is a1 into f1 of s plus a2 into f2 of s. So what is the ROC? ROC is the common range. The common range of two ROCs, ROC in the direction of ROC2. So this is the net ROC. So what is the meaning of ROC? Only for this range of sigma, this function is going to get well defined. So listen carefully. Only for this range of sigma, the function is going to get well defined. That is the meaning of this one. So for f1 of t, the Laplace transform is f1 of s, which is having an ROC1, and for f2 of t, which is having the Laplace transform f2 of s, which is having an ROC2. Then we can say if you are doing a linear combination of these two things, then a1 of f1 of t plus a2 into f2 of t, then we are going to the Laplace transform a1 into f1 of s plus a2 into f2 of s. Then what is the net ROC, which is the common ROC, the common ROC of ROC1 and ROC2. Only in this common ROC, the f1 of s defined, f2 of s is defined. Then only this overall value is also going to get defined. So only in this common ROC, this f1 of s is defined and f2 of s is also defined. Then only the overall function is going to get defined. So this is what I am trying to tell you. So now the next point is, the next formula is e to the power of j omega naught t into u of t. E to the power of j omega naught t into u of t. So listen carefully. I have already told you for u of t, what is the Laplace transform? 1 by s. So 1 by s. So here e to the power of a is nothing but j omega naught. So listen carefully. In a is nothing but j omega naught. So if you are going to multiply e to the power of at, then what is a plus s by s minus a? So s minus a, then a is nothing but j omega naught. So here s is nothing but j omega naught. And what is the, for u of t, what is ROC? The real part of s is greater than 0. So whenever you are going to keep a, then what is the net ROC? The real part of s plus a greater than 0. The real part here a is j omega naught and s is sigma plus j omega naught. So out of this, what is the real part? Sigma plus j omega naught. Out of this, what is the real part? Sigma only. So only sigma we want. Sigma greater than 0. Because for u of t, what is the ROC? The real part of s is greater than 0. For this one, the real part of s plus a greater than 0. S is equal to sigma plus j omega, and a is nothing but j omega naught. So out of this, what is the real part? Sigma. So sigma greater than 0. So this is the net ROC. Then for e to the power of minus j omega naught t into u of t, what is the Laplace transform? I have already told you for u of t, what is the Laplace transform? 1 by s. For e to the power of minus at into u of t, what is the Laplace transform? Replace s by s plus a, replace s by s plus a. Here a is nothing but j omega naught. So therefore you are going to get 1 by s plus j omega naught. For I have already told you for u of t, the Laplace transform is 1 by s, and the ROC is the real part of s is greater than 0. Here now replace s by s plus a, the real part of s plus a greater than 0. Here s is equal to sigma plus j omega, and a is nothing but j omega naught. So from this, what we can say, what is the real part? The real part is sigma. So sigma greater than 0. So this is the overall ROC. Then for the other signal, which is cos omega naught t u of t, cos omega naught t u of t. Cos omega naught t, how you can write in terms of these two things? Cos omega naught t into u of t, how you can write? Is basically, see, u of t take as it is outside. The remaining things we will discuss. So cos omega naught t means I can write like this, right? E to the power of j omega naught t plus e to the power of minus j omega naught t by 2. So if you apply these previous formulas, means these two things we are going to discuss, right? So by doing some linear combination of these two things, we are going to get this one. So listen carefully. By doing the linear combination of these two things, we are going to get this one, right? So what I am going to do? So do the simplification of this one. Then with the help of this process. So listen carefully. Cos omega naught t is nothing but e to the power of j omega naught t plus e to the power of minus j omega naught t by 2. So then what is the Laplace transform? So do the Laplace transform, add these two things and divide by 2. Then finally what you are going to get? Very simple. This is what then we are going to get, which is s by s square plus omega naught square. So this is what we are going to get. And then what is ROC? The common range. What is a common? That sigma is greater than 0. Here also sigma is greater than 0. So what is the common ROC between these two things? Same thing, sigma greater than 0. The common ROC is nothing but sigma greater than 0. Just now we have discussed, right? For linear combination, the net ROC is the intersection or common ROC of two things. So sigma greater than 0. Now for cos omega naught t du of t, what is the Laplace transform? S by s square plus omega naught square with the ROC sigma greater than 0. Then for sin omega naught t into u of t, what is the Laplace transform? Just now we have discussed sin omega naught t. I can write like this: e to the power of j omega naught t minus e to the power of minus j omega naught t by 2j by 2j. I can write like this, right? So if you simplify, then apply the Laplace transform with the help of these formulas, means this one minus this one by 2j. If you simplify, finally you are going to get like this, which is omega naught by s square plus omega naught square we are going to get. So this is also linear combination of these two things. So what is the net ROC? Intersection ROC of these two things. Here sigma greater than 0, sigma greater than 0. So what is the common range here? Sigma greater than 0. So this is the finally we are going to get. So finally you can say for cos omega naught t u of t, the ROC is s by s square plus omega naught square with an ROC sigma greater than 0. And for sin omega naught t u of t, the Laplace transform is omega naught by s square plus omega naught square with an ROC sigma greater than 0. So these point always you have to keep in your mind. So now e to the power of minus at into cos omega naught t into u of t. So this is a f of t. For this we are going to multiply e to the power of minus at. Then I have already told you for f of t, the Laplace transform is f of s and ROC is something. Then for e to the power of minus at into f of t, so what we have to do? Replace s by s plus a. So here wherever s is there, replace s by s plus a. So we are going to get s plus a by s plus a whole square plus omega naught square. Then I have already told you what is ROC. Suppose if this is having some ROC, here this ROC will be real part of s plus a, the real part of s plus a. So the real part of s plus a. So here s is nothing but sigma plus j omega, and here a is nothing but here a only. So what is the real part? Sigma plus a. So sigma plus a greater than 0. So for this ROC we need to apply. So whatever this ROC, same thing we have to apply with this, replacing s by s plus a. That's it. So therefore what we can say, as s is equal to sigma plus j omega and a is as it is. So from this what is the real part? Sigma plus a. Sigma plus a greater than 0. So therefore sigma greater than minus a. Sigma greater than minus a is the ROC for this one. Means only for this range it is going to get well defined. So now the next thing is e to the power of minus at into sin omega naught t into u of t. So you can see for this is a f of t. For this f of t we are going to multiply e to the power of minus at. Then replace s by s plus a. So wherever s is there, replace s by s plus a. So omega naught by s plus a whole square plus omega naught square. And I have already told you same thing. If this is having the ROC is the real part of s, then for this one the ROC will be real part of s plus a. Here s is nothing but s is sigma plus j omega and a we have to add. So for that one, what is the real part? Sigma plus a. So sigma plus a greater than 0. So this ROC we have to apply. Sigma plus a greater than 0. So therefore we can say sigma greater than minus a is the ROC that we are going to get. So only for this range of sigma, this function, this Laplace transform is going to get well defined. So now the next thing is e to the power of at into cos omega naught t into u of t. So here this is f of t. For this we are going to multiply e to the power of at. I have already told you for e to the power of at into f of t, what is the Laplace transform? F of s minus a, and the ROC is real part of s minus a. So here replace s by s minus a. So replace s by s minus a, we are going to get s minus a by s minus a whole square plus omega naught square. And here I have already told you replace s by s minus a. So the real part of s minus a. So the real part of s minus a condition. So the real part of s minus a is nothing but which is here the ROC is greater than 0. So it should be greater than 0. So therefore the real part of s minus a greater than 0. So s is nothing but sigma plus j omega minus a. So what is the real part? Sigma minus a. So sigma minus a greater than 0. So therefore sigma greater than a is the ROC. So only for this range of sigma this function is going to get well defined. So now finally e to the power of at into sin omega naught t u of t. So this is f of t. For this we are going to multiply e to the power of at. Then what is the Laplace transform? F of s minus a. So whenever s is there, replace s by s minus a. We are going to get omega naught by s minus a whole square plus omega naught square. So I have already told you the ROC is real part of s minus a. So here sigma greater than 0. Here the real part of s is greater than 0. So therefore now replace s by s minus a. So therefore the real part of s minus a greater than 0. So therefore s is equal to sigma plus j omega minus a. So sigma minus a greater than 0. So therefore sigma greater than a. So this is the ROC that we are going to get here. So this is the point always you have to keep in your mind. So let me write this part. So same thing. For f of t, the Laplace transform is f of s. The ROC is real part of s. So for e to the power of minus plus a t f of t, it has a Laplace transform f of s plus or minus a, which is having the ROC, the real part of s plus or minus a. So what are these conditions? Same condition we have to apply here also. But after doing some manipulation, we are going to get the changes, right? So this is a point always you have to keep in your mind. So these things always you have to keep in your mind. So these are the very important things. So these are the very important things. So let me write this formulas. Let me write here, so that you can easily able to understand. So no need to write. You can easily able to understand that. So if you know the concept, then you can apply all these things. These are the things we got from the previous concepts only. You know, we have not done anything great. So now the next thing is, so for f of t into u of t, if the Laplace transform is p of s, then listen carefully, this is a very important thing that you always have to keep in your mind, which is minus of f of t into u of minus t, which has a Laplace transform p of s. So both ROC nature is reverse. Both ROC nature is reverse. So this point always you have to keep in your mind. So this formula is very important. Very important. So this formula you have to always keep in your mind. So this is a very important formula. Let me write this formula so that you can easily able to understand. So therefore we can say that if f of t into u of t has the Laplace transform p of s, and here for f of t into so minus f of t into u of minus t, which has the Laplace transform also p of s. So both have the same Laplace transform, but the ROC is reverse. Suppose one is greater than 0 means the other will be less than 0. So both are of opposite ROC. So let me write this formula so that you can easily able to remember. So listen carefully. For f of t into u of t, suppose this is having the Laplace transform p of s. I am going to assume p of s. Then minus of f of t into u of minus t. So this is also going to have the same Laplace transform p of s only. But the only thing is both ROC nature is reverse. So both ROC nature is reverse. Reverse means suppose one is sigma greater than 0, the other will be sigma less than 0. Suppose one is sigma greater than a, the other will be sigma less than a. So that is what I am trying to tell you. So this is a very important formula that you always have to keep in your mind. So for f of t into u of t, if the Laplace transform is p of s, so minus f of t into u of minus t also has the same Laplace transform p of s. But the only thing is both the ROC nature is reverse. If one is greater than 0 means the other will be less than 0. Opposite ROC. So this formula always you have to keep in your mind. So f of t into u of t has the Laplace transform f of p of s, and minus f of t into u of minus t has the Laplace transform p of s. So both ROC, but both the ROC nature is reverse. So both ROC are reverse nature. One is greater than 0 means other is less than 0. One is greater than a means other is less than a. So this is a point you have to keep in your mind. So now the next formula is, suppose if f of t has the Laplace transform f of s, then f of minus t has the Laplace transform f of minus s. So this point always you have to keep in your mind. So listen carefully. For f of t, if the Laplace transform is f of s, then for f of minus t, the Laplace transform is f of minus s. So this is the thing you have to remember. And let me comment on the ROC also. So here, suppose let me assume this is sigma greater than 0. Assume this will be sigma less than 0. So both are the opposite nature, opposite ROC. So both have opposite ROC. So remember this formula. Both have opposite, or you can say both have reverse ROC. So here I am going to write this one also, very important. So let me write here. So let me write this point also. I have crossed this one, it is also right. So here also same thing. Both have the different ROC. Both have the reverse ROC. If one is greater than 0 means other is less than 0. So this is what I am trying to tell you. So for f of t, if the Laplace transform is f of s, then f of minus t has the Laplace transform f of minus s. So f of t as a Laplace transform f of s, then f of minus t as the Laplace transform f of minus s. So if you represent t by minus t means replace s by minus s. Then what you are going to get, both have the reverse ROC. If one is greater than 0 means the other will be lesser than 0. So both ROC, but ROC method is reverse. So both have reverse ROC. So this is you can write like that, both, but the ROC method is reverse, or you can write that they both have the reverse ROC. So at this point always you have to keep in mind, one is sigma greater than 0 means the other will be sigma less than 0. So let me write this formula also, so that you can easily be able to remember. So you can see clearly, if f of t as the Laplace transform f of s, then for f of minus t, the Laplace transform is f of minus s, and both have reverse ROC. So both have reverse ROC. So both have reverse ROC. Reverse ROC means one is greater than 0 means other is lesser than 0. So this is what I am trying to tell you. So this point always you have to keep in your mind. Then now, suppose if f of s is equal to f of minus s, then what is going to happen? Suppose if f of s is equal to f of minus s, then what is the meaning of this one? Then f of t is also even segment. So if f of s is equal to f of minus s, then f of t is also equal to f of minus t. Therefore, what we can say, that it is said to be even signal. So see, here listen carefully. Suppose f of t is equal to f of minus t, then what is going to happen? So for f of t, what is the Laplace transform? F of s. And for f of minus t, what is the Laplace transform? F of minus s. Just now we have discussed. If both are equal, then what we can say? The given signal is said to be an even signal. So this is what I am trying to tell you. If f of t is equal to f of minus t, so for f of t, what is the Laplace transform? F of s. And f of minus t, Laplace transform is f of minus s. If f of t is equal to f of minus t, so definitely f of s is also equal to f of minus s. Like definitely we can say the given signal f of t is the even signal. So this we can easily tell here. Similarly, if f of s is equal to minus of f of minus s, then we can say f of t is an odd signal. This is to be odd signal. Same thing here also. So this concept is for, so here this concept is for this one. So now for this, suppose if f of t, suppose if f of t is equal to minus of f of minus t, then f of t, Laplace transform is f of s. So for f of minus t, as a Laplace transform f of minus s. So keep this minus here as it is. So if f of t is equal to minus of f of minus t, or if f of s is equal to minus of f of minus s, we can say the given signal f of t is said to be odd signal, odd signal, odd signal. So let me write here. 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 If f of t is equal to f of minus t, then for f of t the Laplace transform is f of s, and f of minus t the Laplace transform is f of minus s. Then we can say the given signal is said to be even signal, even signal, even signal, right? Even f of t is said to be even signal. Suppose if f of t is equal to minus of f of minus t, if f of t is equal to minus of f of minus t, so for f of t the Laplace transform is f of s, and for f of minus t the Laplace transform is f of minus s. If these are equal, then we can say the given signal f of t is said to be odd signal, odd signal. So we can comment on the nature of the signal f of t either in time domain or either in the s domain also we can comment. So now, suppose if f of s is not equal to f of minus s, or if it is not equal to minus of f of minus s, then we can say f of t is an either even signal or not odd signal. So if f of s is not equal to f of minus s, or it is not equal to minus of f of minus s, then we can say the given signal f of t is neither even signal nor odd signal. So by default we can say, so therefore we can say if f of s is not equal to f of minus s, or it is not equal to minus of f of minus s. So what is the meaning of this one? F of t is not equal to f of minus t, or f of t is not equal to minus of f of minus t. The meaning of it same as it is. So therefore we can say simply that the given signal is neither even signal nor a odd signal. So listen carefully. If f of t is not equal to f of minus t, if f of t is not equal to f of minus of f of minus t, or if f of s is not equal to f of minus s, or if f of s is not equal to minus of f of minus s, then we can say the given signal is said to be neither a even signal nor an odd signal. So these things always you have to keep in your mind. So now the next thing is, the next important point that I wanted to tell you is very simple, which is, suppose, see, if you know f of t, you know how to figure out the f of s. But what is the vice versa? What is the vice versa equation? Which is, if you know f of s, then how to get the f of t, which is f of t is equal to 1 by 2 pi j integration of sigma minus j infinity to sigma plus j infinity f of s into e to the power of s t into ds. Instead of doing this, just go for the partial fractions. If you know f of s, go for the partial fractions and then apply the formulas that we have learned and then get the f of t, right? Instead of doing this one, you can directly apply the partial fractions. I've already told you, if you know f of s, just apply the partial fractions and apply the formulas what we know, then we can get back the f of t, right? F of t. So, but I request you to remember this formula also. This formula also you have to understand. So let me write this formula so that you can easily able to recall in the examination time. So here, I already told you, if you know f of t, how to get the f of s, I already told you, f of s is equal to integration of p is equal to minus infinity to plus infinity, which is f of t into e to the power of minus st into dt. I already told you, right? So now, here ROC is the real part of plus. So now, here, the reverse. What is the reverse thing? F of t is equal to 1 by 2 pi j, integration of sigma minus j infinity to sigma plus j infinity f of s into e to the power of st into ds. See, if you go for the Fourier transform, I already told you Fourier transform, f of omega is equal to integration of t is equal to minus infinity to plus infinity f of t into e to the power of minus j omega t into dt is a Fourier transform. So how to get the f of t? I already told you that is 1 by 2 pi integration of omega is equal to minus infinity to plus infinity f of omega into e to the power of plus j omega t into d omega. Same as it is, right? Same as it is. Nothing changed we have did. Same as it is. So here replace us by j omega. We got this expression. So now here what to do is very simple. So here basically here nothing but omega is equal to minus infinity is sigma minus j infinity, and this is sigma plus j infinity. So this is sigma minus j infinity and this is the sigma plus j infinity. So you have to add some real. So sigma plus j infinity and sigma minus j infinity. Here this is nothing but f of s. F of s we are doing e to the power of j omega is nothing but s. E to the power of s t into here s is nothing but d omega is nothing but here s. So keep here j extra. So what I want to do is very clear. So if you compare, what is the thing that we have to do? So if you are going to compare these two things, what we have to do is very simple. We have kept an extra j, 2 pi j we have kept. Integration sigma minus j infinity, sigma plus j infinity, f of s, and here e to the power of s t into ds. So this is what we have did. So if you remember this one, we can get this one very easily. Here just keep an extra j. Keep an extra j here. This is sigma minus j infinity, this is sigma plus j infinity. Here f of s, e to the power of, this is s, right? S is nothing but j omega. So j omega as e to the power of s t into, here this is ds. So if you remember this one, you can getting this one is very simple. Here I kept the extra j, sigma minus j infinity, here sigma plus j infinity, here f of s, and e to the power of s t, here ds. That's it. So it is a Fourier transform and it is a Laplace transform. So these things always you have to keep in your mind. So if you know this one, keep an extra j here, keep an extra j here, and this is ds, here e to the power of st, and f of s, is sigma minus j infinity, sigma plus j infinity. So these things always you have to keep in your mind. So now the next thing is some more formulas. So listen carefully. For f of t, if the Laplace transform is f of s, which is having an ROC 1. H of t is having the Laplace transform h of s, which is having an ROC 2. Then what is the convolution? F of t convolution of h of t. I have already told you the convolution in time domain we needs to product in the frequency. S is nothing but frequency domain only. So therefore we can say that the convolution in time domain we needs to product in the frequency domain. So therefore, what we can say, f of s into h of s. So what is the net ROC? Net ROC is nothing but the combination, or you can say the intersection of the ROC1 and ROC2, because only in this common range only the f of s is defined and h of s is defined. Only in this common range, so therefore the overall product is also going to get defined. So therefore we can say in this common range both the f of s and h of s are defined. Then only the product is also going to get defined. So therefore this is what I am trying to tell you. So if f of t has the Laplace transform f of s, which is having an ROC1, and h of t is having the Laplace transform h of s, which is having an ROC2, then f of t convolution of h of t, which have the Laplace transform f of s into h of s, it's having ROC1 intersection of ROC2. Because why this like this? In this common ROC only, the f of s is defined and h of s is defined. Then only the product is also going to get defined. So the convolution of time domain is always going to change to modifies to the product in the frequency domain. So this point, as I already told you so many number of times, I already told you. So now the next formula is, suppose if f of t is having the domain Laplace transform f of s with an ROC1, and h of t is having the Laplace transform h of s, it is having an ROC2. Suppose same thing again, right? I have not changed anything, right? So I have kept as it is. So if y of t is equal to f of t convolution of h of t, so if y of t is equal to f of t convolution of h of t, then y of s is nothing but f of s into h of s. Then what is h of s? H of s is equal to y of s by f of s. So h of s is called as a transfer function. So this I have already told you. So what is the net ROC? The net ROC is the intersection of the two ROCs. So the net ROC is nothing but intersection of the two ROCs, ROC1 and ROC2, because only in this common ROC both f of s and h of s is defined. So therefore we can say that the overall function is also going to get defined. So therefore we can say for f of t, the Laplace transform is f of s and its ROC is ROC1, and for h of t, the Laplace transform is h of s and its ROC is ROC2. Then y of t, if it is convolution of the two things, f of t convolution of h of t, then y of s is equal to f of s into h of s. F of s is defined in ROC1 and h of s is defined in ROC2. So if you want to do the product, then both should be defined in a common ROC. So which is the intersection of the two ROCs. So then only in this common ROC both are going to get defined. Then only the product is also going to get defined. So what is h of s? H of s is equal to phi of s by f of s. So this is nothing but which is called as the transfer function of the given system. So h of s is nothing but y of s by f of s. So this is called as a transfer function of the given system. So these points always you have to keep in your mind. So now the next thing is for f of t, if the Laplace transform is f of s, and for f of t minus a, the Laplace transform is e to the power of minus as into f of s. So listen carefully. For f of t, the Laplace transform is f of s. Then for f of t minus a, the Laplace transform is f of s into e to the power of minus as. So this formula always you have to keep in your mind. So for f of t, the Laplace transform is f of s, and for f of t minus a, the Laplace transform is e to the power of minus as into f of s. So these points always you have to keep in your mind. So therefore you can say for f of t, the Laplace transform is f of s. Then for f of t minus a, the Laplace transform is e to the power of minus as into f of s. So finally, suppose f of t plus a means f of s into e to the power of plus as, right? So this is a thing here. So for f of t, the Laplace transform is f of s. Then f of t minus a, the Laplace transform is e to the power of minus as into f of s. So this point always you have to keep in your mind. So f of t plus a means f of s into e to the power of plus as. So let me write here the general formula. Let me write here the general formula. So what is the general formula? We can say that for f of t, if the Laplace transform is f of s, then for f of t minus plus a is nothing but if you learn the Laplace transform minus plus as into f of s. So this is what I am trying to tell you. So for f of t, if the Laplace transform is f of s, if f of t minus or plus a is the Laplace transform with the power of minus plus as into f of s, then minus plus is also minus, and the plus is also plus. So this formula always you have to keep in your mind. So Let's go for the another formula, which is here. Suppose if f of t is having the Laplace transform f of s, then d by dt of f of t as a Laplace transform s into f of s, and the nth derivative of f of t will have the Laplace transform as the power of n into f of s. So this one always you have to keep in mind. So f of t, if it is having the Laplace transform f of s, then first derivative of f of t will have the Laplace transform s into f of s, and the derivative of f of t will have the Laplace transform as the power of n into f of s. So this is our point always you have to keep in mind. So therefore we can say that for f of t, if the Laplace transform is f of s, then the first derivative of f of t will have the Laplace transform s into f of s, and the nth derivative of f of t will have the Laplace transform as the power of n into f of s. So finally I can say if f of t has a Laplace transform f of t, then first derivative of f of t has the Laplace transform s into f of s, and the nth derivative of f of t will have the Laplace transform as the power of n into f of s. So let me write here the formula so that you can easily able to understand. So for if f of t has a Laplace transform f of s, then nth derivative of f of t has the Laplace transform as the power of n into f of s. So these points always you have to keep in your mind. So like this always you have to keep all the formulas in your mind. Now we are going to discuss some more points, which is for f of t, if the Laplace transform is f of s, then for f of t minus t naught, what's the Laplace transform in the power of minus s t naught into f of s, and for f of t plus t naught, what's the Laplace transform, which is e to the power of s t naught into f of s. Just now we have discussed, right? So just now we have discussed, right? This is the same thing here, right? So in place of a, I replaced a by t naught. That's it. So what I can say, this is same as we discussed. So for f of t, if the Laplace transform is f of s, then for f of t minus a, what's the Laplace transform with the power of minus as into f of s? Here a is nothing but t, here plus a, here minus a. Here minus a means here also minus a. Here plus a means here also plus a. Just now we discussed, right? So same as it is. So for f of t, the Laplace transform is f of s, and for f of t minus plus a is nothing but e to the power of minus plus as into f of s. Here minus plus, here minus, here plus, here also plus. So this one just now we have discussed, so no need to further explain. The next thing is, for f of t, if the Laplace transform is f of s, which is having an ROC, which is having a basically some ROC. So for t into f of t, which has the Laplace transform, which is minus d f of s by ds. So ROC here also both have the same ROC. So ROC will never change. So let me give you the general expression. So what is general expression? T to the power of n into f of t. For this one, what is the Laplace transform? The Laplace transform is minus 1 over the power of n into nth derivative with respect to s. So ROC is same as it is. So let me write here. So let me write here so that you can easily able to understand. So let me write here. So now let me write here. So therefore, for f of t, if the Laplace transform is f of s, and for f of s, then for t to the power of n into f of t, the Laplace transform, the general expression is minus 1 over the power of n into nth derivative of f of s with respect to s. So both have the same ROC. So ROC is same. So ROC will never change. So ROC is same as it is. So ROC will never change. So therefore, for f of t, the Laplace transform is f of s. So for t to the power of n into f of t, the Laplace transform is minus 1 over the power of n into nth derivative of f of s with respect to s. So ROC will be same as it is. It will never get changed. In place of n, if you substitute 1, then what you are going to get? T into f of t as the Laplace transform. Minus 1 over the power of 1 is minus 1. So minus 1 into first derivative. So df of s by ds. So this is what we can say. So finally I can say that for f of t, the Laplace transform is f of s, which is having an ROC, some ROC. So for t to the power of n into f of t, which has the Laplace transform, minus 1 over the power of n into nth derivative of f of s with respect to s. So in both the cases, ROC is same. ROC will never get changed. So with the help of this transformation. So this point always you have to keep in your mind. So now the next thing is for t to the power of n into u of t. So whatever the concept that we have learned, same concept now we are going to apply. You will see what is going to get happen. So I have already told you. I have already told this important formula, right? T to the power of n into u of t is nothing but what is the formula? N factorial by is the power of n plus 1. So this formula, as I have already told you. So see, basically, see very carefully. For u of t, what is the for u of t, what is the Laplace transform 1 by s with ROC, the real part of s greater than 0. So for take the power of n into u of t, just apply this formula. Finally, you are going to get n factorial by s the power of n plus 1. ROC is same as it is, which is sigma greater than 0. So let me write here so that you can easily able to understand. See, I've already told you, for u of t, what is the Laplace transform? The Laplace transform is 1 by s. The ROC is the real part of s is greater than 0. I've already told you, right? So now, for t to the power of n into u of t. So if you apply this formula, what is the formula? Minus 1 over the power of n into nth derivative of f of s with respect to s. So if you solve this one, finally what you are going to get, which is, if you solve this one, finally you are going to get n factorial by s the power of n plus 1, that we are going to get. And ROC is same, right? Just now we have discussed. Same ROC, the real part of s is greater than 0. The real part of s is nothing but sigma. So sigma is greater than 0 in both these cases. So this is what I am trying to tell you. So now, the next thing is, e to the power of minus 80 into u of t. This one I have already told you. E to the power of minus 80 into u of t. See, for u of t, what is the Laplace transform 1 by s? So for e to the power of minus 80, what is the Laplace transform? So e to the power of minus 80 means I have already told you, for u of t, what is the Laplace transform 1 by s? With the ROC real part of s greater than 0. Then I have already told you, whenever you are going to multiply by e to the power of minus 80, then you have to replace s by s plus a. In the ROC also you have to replace s by s plus a. This one I have already told you. So therefore, u of t has the Laplace transform 1 by s. So replace s by s plus a. We are going to get 1 by s plus a. And I have already told you, for u of t, the ROC is the real part of s greater than 0. So here, what is the ROC? Replace s by s plus a. So real part of s plus a greater than 0. Here s is equal to sigma plus j omega plus a. The real part is sigma plus a. So sigma plus a greater than 0 is nothing but sigma greater than minus a. Then comes the e to the power of 80 into u of t. I have already told you, for u of t, the Laplace transform is 1 by s. And the ROC is the real part of sigma, the real part of s greater than 0. So if you are going to multiply e to the power of 80 means replace s by s minus a. So you are going to get 1 by s minus a. And here also, replace s by s minus a. So real part of s minus a less than 0. So s is equal to sigma plus j omega. So the real part is sigma minus a less than 0. So sigma minus a greater than 0. Because for u of t, what is the ROC? The real part of s greater than 0. So replace s by s minus a, we are going to get finally the real part of s minus a is nothing but sigma minus a. So sigma minus a greater than 0, which is nothing but sigma greater than a. So now we have learned this concept, right? So now for this one, I am going to multiply by t to the power of n. So this is the f of t I am going to assume. For this one, I am going to multiply by t to the power of n. Then what is going to happen? I have already told you what is the formula. So here, listen carefully. Listen carefully. You see, t to the power of n into u of t, just now we have discussed. So t to the power of n into u of t, just now we have discussed what we have discussed. T to the power of n into u of t we have learned, which is n factorial by, here only I have written. See, n factorial by s the power of n plus 1 with the ROC sigma greater than 0. So now if you are going to multiply by e to the power of minus 80 means replace s by s plus a. So replace s by s plus a, we are going to get n factorial by s plus a on the power of n plus 1. So whenever you are going to multiply e to the power of minus 80 means what is ROC? The real part of s plus a. The real part of s plus a. So here real part of s greater than 0. So replace s by s plus a. So real part of s plus a greater than 0 means sigma plus a greater than 0. So therefore sigma is greater than minus a. Similarly, e to the power of n into e to the power of 80 into u of t. See, same thing. E to the power of n into u of t, which is n factorial by s to the power of n plus 1, and the real part of s is greater than 0. So if you are going to multiply e to the power of 80 means replace s by s minus a. So we are going to get n factorial by s minus a over the power of n plus 1. And here what is ROC? Replace s by s minus a. So therefore, the real part of s minus a greater than 0. So then s is equal to sigma plus j omega. The real part is sigma minus a greater than 0. So sigma greater than a. So this is the thing that you have to keep in your mind. So if you know the basic formulas, I think this is a very piece of cake. So now the next thing is, if f of t has the Laplace transform f of s, which is having an ROC. So minus here, basically for f of t, if the Laplace transform is f of s, which is having an ROC, For minus into f of t as the Laplace transform minus into f of s, the ROC is same. So just we have what we have did for f of t we have multiplied by minus. So f of s should be also multiplied by minus. Then only both are same, right? So basically what I have did is I have multiplied the minus on both sides. If we cut minus minus again, we are going to get same thing. The ROC will never change. It will remain as it is because here also minus I am going to cancel. Here also minus I am going to get cancelled. So same as it is, right? So therefore the ROC is same. We can say same ROC. So for f of t, if the Laplace transform is f of s, then minus into f of t will have the Laplace transform minus into f of s. The ROC is same. What we have did, just we have multiplied the minus on both sides. So minus into f of t has the Laplace transform minus into f of s. So ROC is same as it is. Just we have multiplied the minus on both sides. So the function is same, right? If the minus is cancelled, same as it is. So therefore we can say the ROC is same. The ROC is same. So now the next point is for delta of t, if the Laplace, see I have already told you for delta of t what is the Laplace transform 1 and what is ROC entire display. Means it is defined at each and every value of t s. This one I have already told you, right? So for delta of t, the Laplace transform is 1 and the ROC is it is defined at each and every value of the s in the s plane. Then delta of t minus t naught, I have already told you the basic formula which is for f of t, if the Laplace transform is f of s, then f of t minus a has the Laplace transform e to the power of minus a is into f of s. Here, delta of t minus t naught, a is nothing but t naught. So e to the power of minus a s into f of s. A is equal to t naught. So e to the power of minus t naught into s into f of s is nothing but 1. So e to the power of minus s t naught. So it is having the ROC entire s plane except sigma is equal to minus infinity. Suppose sigma is equal to minus infinity, then what is going to happen? Minus can minus will become positive. So e to the power of infinity is nothing but it is undefined. So therefore it is defined at each and every value of s except that sigma is equal to minus infinity. Similarly, we can say delta of t plus t naught. So f of t plus a is nothing but it has the Laplace transform e to the power of s into f of s. Here a is equal to t naught. So if we supply, we are going to e to the power of t naught s into f of s is 1. So it is defined at each and every value of s except that sigma is equal to infinity. Suppose if sigma is equal to infinity, then what is going to happen? E to the power of infinity into t naught is nothing but infinity, so it is undefined. So what is the meaning of defined? Means it is going to give you finite value. Undefined means it is going to give you infinite value. And that is the meaning of defined and undefined. Defined means it is going to give you a finite value. Undefined means it is going to give you an infinite value. So this one always you have to keep in your mind. So finally, I can say for delta of t, the Laplace transform is 1. So it is defined at each and every value of the s, at each and every value of the point in the s plane. For delta of t minus t naught, the Laplace transform is e to the power of minus s t naught. It is defined at each and every value of the s except at sigma is equal to minus infinity. Similarly, delta of t plus t naught, it has the Laplace transform e to the power of s into t naught. So it is defined at each and every value of the s plane except at sigma is equal to infinity. Suppose if substitute here sigma is equal to minus infinity, we are going to get e to the power of infinity which is undefined. And here also if substitute sigma is equal to infinity, so e to the power of infinity you are going to get it is also undefined. So defined means you are going to get a finite value. Undefined means you are going to get a infinite value. So this point always you have to keep in your mind. Now we are going to discuss the another point which is e to the power of minus at into u of t as a Laplace transform 1 by s plus a with ROC sigma greater than minus a. So listen carefully how we got this one. Let me explain. So for u of t, you know what is the Laplace transform 1 by s. And the ROC is the real part of sigma s greater than 0. So if whenever you are going to multiply e to the power of minus at, I have already told you replace s by s plus a. So it will become 1 by s plus a. And the real part, now the ROC will become the real part of s plus a greater than 0. So therefore sigma plus a greater than 0. So therefore sigma greater than minus a. The next point is, so basically what I have did here, I have replaced t by t minus t naught. So this is nothing but f of t minus t naught. So if this is f of t means this is f of t minus t naught. I have already told you what is the formula. F of t minus a will have the Laplace transform e to the power of minus a s into f of s. E to the power of minus a is nothing but t naught. So e to the power of minus a is nothing but t naught. So t naught into s into f of s. F of s same as this one, just 1 by s plus a. And what is the ROC? ROC will remain same as it is. ROC will remain same as it is. So this is a point I have to tell you here. So let me write here. So let me write here also. So here the ROC is same. Here also I am going to write. which is ROC is same. ROC is same. ROC is not going to get interchanged. It will be remain as it is, as it is. So let me write here also this one. Let me write here so that you can easily able to understand. So this formula here. So here I'm going to write this one. The ROC is same. Here the ROC is same as it is. It will never get changed. Whatever the ROC here, whatever this ROC here, same ROC here as well as same ROC here also. So this point always you have to keep in your mind. So here also same thing. This is a same thing, right? So here also same ROC, same ROC. ROC will never get changed. It will remain as it is. So this is what I am trying to tell you. So here also ROC is same. Suppose if I am going to replace t by t plus t naught, then what is going to happen? So f of t plus a means I have already told you what is the Laplace transform. E to the power of minus as into f of s. Here is nothing but t naught. So e to the power of, here minus means here minus, here plus means here plus. E to the power of as into f of s. A is nothing but here t naught. So e to the power of s t naught into 1 by s plus a. The ROC is same as it is. Whatever this ROC, same ROC you are going to get here. So this is what I have only told you so many number of times. The ROC will remain as it is. So now the next thing is rational Laplace transform. So rational Laplace transform means h of s is equal to s minus a1 into s minus a2 goes on by s minus b1 into s minus b2 goes on. A rational means p by q format. So rational Laplace transform means if the Laplace transform in the format of p by q, then it is first rational Laplace transform. Very simple, right? So what is the meaning of rational number? Rational number means if any number is in the format of p by q, then we say it is a rational number. So what's the meaning of rational number? If any number in the format of p by q, then we say it is a rational number. So here rational Laplace transform means if the Laplace transform is in the format of p by q, then we say it is a rational Laplace transform. So it's a very easy thing. So what's the meaning of rational number? If the number is in the format of p by q, then we say it is a rational number. Similarly, here also the rational Laplace transform is if the Laplace transform is in the format of p by q, then we say it is a rational Laplace transform. So h of s is equal to, it has numerator and denominator. S minus a1 into s minus a2 goes on, s minus b1 into s minus b2 and goes on. The numerator roots are called as zeros and the denominator roots are called as the poles. So the numerator roots are called as zeros and the denominator roots are called as the poles. So what are the zeros? A1, A2 and goes on. What are the poles? V1, V2. So listen carefully. The numerator roots are called as the zeros and the denominator roots are called as the poles. The numerator roots are called as the zeros and the denominator roots are called as the poles. So what are the zeros? A1, A2 and goes on. The poles are V1, V2. So finally, the numerator roots are called as the zeros and the denominator roots are called as the poles. The roots are A1, A2 and goes on and the poles are V1, V2 and goes on. If the transfer function of LTI system is rational and if its ROC is right-sided, then the system is said to be causal system. Listen carefully. If the transfer function of LTI system is rational and if its ROC is right-sided, then the system is said to be causal system. So what is the meaning of this one? Say, suppose for a given LTI system, we have figured out the transfer function. The transfer function is nothing but h of s. See, h of t is the impulse response. So if you find the Laplace transform of h of t, then you are going to get h of s. That is the transfer function. If it is in the rational, if the transfer function is in the format of the rational, and if its ROC is the right-sided, then we can say that the LTI system is said to be causal system. Causal system means the output is independent of the future inputs. It can depend only on the present input or past input, while it is independent of the future input. That is the meaning of that one. So therefore we can say that if the transfer function of the LTI system is rational and if its ROC is right-sided, then the system is said to be causal system. So finally I can say if the transfer function of LTI system is rational and if its ROC is right-sided, then the system is said to be causal system. So this point always you have to keep in your mind. So if the transfer function of the LTI system is rational and if its ROC is right-sided, then the system is said to be causal system. So what I have done to you is very simple. Suppose you take an LTI system and try to figure out the impulse response of the LTI system and then try to find the Laplace transform of the h of t, which is nothing but h of s. That is called the transfer function of the LTI system. If it is in the format of the p by q and if its ROC is right-sided, then default we can say that system is said to be causal system. Is said to be causal system. Causal system. So finally, listen carefully. What I am trying to tell. So suppose you take an LTI system. For the LTI system, if you give an impulse input, we are going to get the impulse response. So for that, for this impulse response, try to figure out the Laplace transform. That is called the transfer function. And if the transfer function is in the format of p by q, it's in the format of relation. And also, if its ROC is right-sided, then therefore we can say the system is said to be causal system. So therefore we can say the transfer function of the LTI system is rational, and if its ROC is right-sided, then the given LTI system is said to be causal system. So now the next point is, so now we can see e to the power of et into u of minus t as the Laplace transform minus 1 by s minus a with a sigma less than a. Why it is like this? Let me explain. So why it is like this? Let me explain in a very detailed manner. So what we have learned, just let me write here. So what we have learned previously, so e to the power of minus at into u of t, which has the Laplace transform 1 by s plus a. Just now we have discussed that sigma greater than minus a. Just now we have discussed that. So now, suppose now, this is f of t I am going to assume. Suppose replace f of t by f of minus t. Then what is going to happen? It will become e to the power of at into u of minus t. So for f of t, the Laplace transform is f of s, and f of minus t is the Laplace transform f of minus s. So f of minus s, right? F of minus s. So f of minus s. So replace s by minus s, then what we are going to get? 1 by minus s plus a. So take minus 1, minus common with the denominator. So we come up forward, which is minus 1 by s minus a. So we can write like this one. If we take minus 1, minus common with denominator, then we are going to get 1 by minus of s minus a, which is nothing but minus 1 by s minus a. So what is the ROC? I have already told you some important formula which now we have discussed. The ROC will be reverse. The ROC will be reverse. I have already told you that. So for f of t, the Laplace transform is f of s, and for f of minus t, the Laplace transform is f of minus s. The ROC is reverse. ROC is reverse. So then sigma greater than minus a. So what is the reverse ROC? Sigma less than. I think this is sigma greater than minus a means what is the reverse here? Sigma less than a. Sigma less than a. But according to my view, reverse means what I can say. Here, let me go for the explain. Suppose this is minus a. So sigma greater than minus a is this one, right? So this is ROC. So this is ROC. Reverse means it should be here, right? Here, right? So this is a reverse ROC. So reverse ROC. But here they are doing sigma less than a. So here I have small dot here. So here I have small dot. Now what is the meaning of reverse ROC? The ROC means that is reverse. Is it mirror image? Is it mirror image they are saying? Is that saying mirror image or just reverse? So that I need to clarify. But here, suppose if you substitute sigma less than a, then what is going to happen? Suppose sigma less than a means I can substitute 0, right? If I can substitute 0, if you substitute 0, what are you going to get? Then you are going to get minus 1 by 0 minus a. Yes, it is defined. So definitely we can say that yes, it is defined. So see, what is the meaning of reverse? Mirror image. Reverse. So mirror image. It is a mirror image. Mirror image. So let me explain here. I think you are confused. So this concept just now I got to know. So I need to explain for you so that you can easily able to understand. So this point always you have to keep in your mind. So it's a mirror image. Reverse means mirror image. The ROC reverse means mirror image. Mirror image. So listen carefully. Suppose for the first case, what is the ROC? Sigma greater than minus a. So this is minus a. So this is the ROC. So this is the ROC. So what is the reverse? We can say mirror image. So what is the mirror image of this one? So mirror image of this one is very simple. So this is the right. So mirror image like this one. So this is the mirror image. This is a plus a and like this. Sigma less than a. So this is the reverse. So what is the meaning of reverse? Reverse means mirror image. Suppose if you substitute sigma is equal to 0. It is going to get defined, right? It is defined. It is defined. Minus 1 by minus a. Minus 1 by minus a. It is defined. So therefore we can say, yes, it is defined. So therefore we can say sigma less than a. So what is the meaning of reverse? Reverse means mirror image. It is a mirror image. Just for this one, keep a mirror here, and then you are going to get this here. So this is also mirror image. Reverse. Reverse means not like this one. Reverse means mirror image. So this is the what we are going to get. Yes, this is the right thing. Then here what I have did, I replace t by t plus t naught. Then what is the meaning of this one? If suppose this is f of t, I have did here f of t plus t naught. Then what is the meaning of this one? F of t plus t naught. So what is the meaning of this one? I have already told you. So here t plus a is nothing but e to the power of as into f of s. Here a is nothing but t naught. So e to the power of t naught into s. F of s same as it is. The ROC will be remain as it is. I already told you with the help of this, the ROC will never change. So this point I already told you. So whenever you are going to apply this one, the ROC will never change. So ROC will same as it is. The sigma less than a. And you can say sigma not equal to infinity. Sigma less than a and sigma is not equal to infinity. Why it is like this? Sigma less than a. Actually sigma is not equal to infinity. In that case, sigma should be not equal to minus infinity. In that case, not plus infinity, because already sigma is less than a. Sigma is less than a means we can say it is in this format, right? So in this format, it is coming here. It is coming here. It is coming here. Suppose if sigma is equal to plus infinity, then what is going to happen? 1 by infinity minus a. See, already that point is not there. So here, don't think about this one. Only think about up to here. Sigma is less than a. Suppose sigma is equal to infinity, then what is going to happen? That we will say here. 1 by infinity minus a is nothing but 1 by infinity. 1 by infinity is nothing but 0. 0 you are going to get. So this is all, everything 0 to everything is again 0 you are going to get. Suppose if sigma is equal to minus infinity, then what is going to happen? Then minus 1 by minus infinity minus a. Minus infinity minus a is not minus infinity. So minus cancels, 1 by infinity is 0. So e to the power of minus infinity. So it will become e to the power of minus infinity is nothing but we are going to get 1 by e to the power of infinity. It is nothing but 1 by infinity is nothing but 0. So 0 into 0 is nothing but 0. So you are going to get a finite value. So we are going to get a finite value. So therefore, sigma is not equal to infinity only. It is correct, because as sigma is equal to minus infinity, you are going to get certain finite 0 value you are going to get. Means it is defined. It is defined. So sigma is not equal to infinity. Because what happens if you so this one just remove this from here. The remaining thing is same. So here what I have did in place of t, I substitute t minus t naught. Then what I have got here, whatever this t, I have replaced t by t minus t naught. Then what is the formula? If t minus t naught is something but f of t minus t naught is nothing but e to the power of minus t naught s into f of s. So e to the power of minus t naught s into f of s. F of s same. The ROC will never get changed. So the ROC is remain as it is. Sigma less than a. The only thing I want to tell you, reverse means it is a mirror image. It is a mirror image. Reverse means not if it is what does it mean? See here, sigma less than sigma greater than minus a. So this is sigma greater than minus a. Reverse means not sigma less than minus a. Reverse means we can say that it is a mirror image. It is a mirror image. Reverse means it is a mirror image. So this point I have not known earlier. So this one you have to remember, because from this point only I got to know. So therefore you have to remember, reverse means it is a mirror image. It is a mirror image with respect to y-axis. It is a mirror image with respect to y-axis. That is the meaning of that one. So this point always you have to keep in your mind. So now then for f of t, so the next point is for f of t, the Laplace transform is f of s. Then integration of minus f to t, f of t dt. I can write like this: f of t combination of u of t. I have already told you, right? Then what is the see the combination tangent leads to the product in the complex in the frequency domain. So f of s into u of s. U of s is nothing but 1 by s. Just now we have discussed. So f of t into 1 by s is nothing but f of s by s. So f of s into 1 by s is nothing but f of s by s. So this point I have already told you. So f of t has a Laplace transform f of s. Then integration of minus m to t f of t dt. It is nothing but you can write like this: f of t combination of u of t. So therefore what we can say, and the conversion time domain leads to the product in the frequency domain. So f of s into u of s. U of s as the Laplace, for u of t was the Laplace transform, u of s is equal to 1 by s. So f of s into 1 by s nothing but f of s by s. So this one always you have to keep in your mind. The next thing is, for f of t, what is the Laplace transform? F of s is equal to integration of t is equal to minus m to plus t. F of t into e to the power of minus st into dt. So let me take this as the first equation. For f of t, the other Laplace transform is f of s is equal to integration of t is equal to 0 to infinity. F of t into e to the power of minus st into dt. So this is the second equation. So if you see clearly, for the first equation, we are doing the integration from e is equal to minus infinity plus infinity. But for the second equation, we are doing the integration from t is equal to 0 to infinity. So therefore, we can say this first equation is called as the two-sided transform or the bilateral transform because we are taking the time domain from minus infinity to plus infinity. So LHS we are going to consider and also we are going to consider. So because of this, we can say two-sided transform or the bilateral transform. Whereas this one, only one side we are going to get considered. So that is the result is called as the one-sided transform or the unilateral transform. So up to now, whatever we studied, it is all for the bilateral transform. So up to now, whatever the things that we have studied, all those are for the bilateral transform only. So whenever we are doing the integration from t is equal to minus infinity to plus infinity, we are going to basically take all the two sides we are going to consider. So it is called the two-sided transform or the bilateral transform. But if you are going to consider only one side, then we say it is the one-sided transform or the unilateral transform. So this is the part you have to keep in mind. So therefore, we can say that this is basically the one-sided. So this is the two-sided transform or the bilateral transform, and this is called the one-sided transform or the unilateral transform. So I can only say one thing. If you are going to consider two sides, it is called the two-sided transform or the bilateral transform. But if you are going to consider only one side, then it is called as the unilateral transform or the one-sided transform. So finally, I can say if you are going to consider the two sides, then it is called as the two-sided transform or the bilateral transform. But in case if you are going to consider only one side, then it is called as a one-sided transform or the unilateral transform. So whatever the concepts that we have studied, it is for the two-sided. So finally, I can say only one important thing. Whenever you are going to consider the two sides, it is called as the two-sided transform or the bilateral transform. But if you are going to consider only the one side, then it is called as the unilateral transform or the one-sided transform. So therefore, in the case of equation 1, we are doing the integration from t is equal to minus 70 plus 70. So we are going to consider the two sides of the segment f of t. So because of that, it is called as the two-sided transform or the bilateral transform. Whereas here we are doing the integration from t is equal to 0 to infinity only, means only we are considering f of t only from t is equal to 0 to t is equal to infinity. So because of that, we are going to consider only the one side. So therefore, because of that, it is called as the one-sided transform or the unilateral transform. So after now, what are the concepts that we have studied? It is for the two-sided transform. So now the next thing is, so for f of t, so now I am going to do the unilateral. So I am going to do the unilateral concept. I am going to discuss unilateral. So unilateral concepts I am going to discuss here. So if f of t, if you are going to do the unilateral transform, then we have got the f of s. So for d by dt of f of t, if we do the unilateral transform, we are going to get s into f of s minus f of 0 minus. For d square f of t by dt square, if we do the unilateral transform, then we are going to get s square into f of s minus s into f of 0 minus f dash of 0 minus. Suppose if you go for the third derivative, so if you go for the third derivative, d cube and dt cube f of t, if you do the unilateral transform, then we are going to get s cube into f of s minus s square into f of 0 minus s to the power of 1 into f dash of 0 minus s to the power of 0 into f double dash of 0 minus. So these things always you have to keep in your mind. So therefore, suppose it is fourth derivative. So fourth derivative. This fourth derivative is, what is the formula? If you put a unilateral transform, then we are going to get s to the power of 4 into capital F of s minus s cube into f of 0 minus s to the power of 2 into f dash of 0 minus, then s to the power of 1 into f double dash of 0 minus s to the power of 0 into f double dash of 0 minus. So this point always you have to keep in your mind. So therefore, these are the unilateral transform. So if you apply the unilateral transform, this is a thing that you are going to get. So for f of t, if you apply the unilateral transform, we are going to get f of s. And for d f of t by dt, if you apply the unilateral transform, we are going to get s into f of s minus f of 0 minus. For d square f of t by dt square, if you apply the unilateral transform, we are going to get s square into f of s minus s to the power of 1 into f of 0 minus s to the power of 0 into f dash of 0 minus. For d cube of f of t by dt cube, we are going to, if you apply unit transform, we are going to get s cube into f of s minus s square into f of 0 minus s the power of 1 into f dash of 0 minus s the power of 0 into f double dash of 0 minus. For fourth derivative of f of t, for fourth derivative, if you apply the f of t, then for this one, if you apply the unit transform, we are going to get s the power of 4 into f of s minus s cube into f of 0 minus s square into f dash of 0 minus s the power of 1 into f double dash of 0 minus s the power of 0 into f double dash of 0 minus. Suppose in case if you apply the, suppose in case if you apply the bilateral transform, then what we are going to get? This one I already told you, and let me get to this concept. These extra factors won't come. Only the first term you are going to get. So only the first term that you are going to get if you apply the bilateral transform. All this, then the second terms, third terms, all these things won't be going to get. So for f of t, if you apply the bilateral transform, then we are going to get f of s. Similarly, for f dash of t, if you apply the bilateral transform, then we are going to get s into f of s. These remaining terms won't get. Similarly, for nth derivative. So, for nth derivative of f of t with respect to as at t to the power of n, if you apply the bilateral transform, then we are going to get s to the power of n into f of s. So, these extra factors won't get. So, in the case of bilateral transform, these extra factors won't get. But in the case of unilateral transform, we are going to get these extra factors because at t is equal to 0 minus what is the value of the function that they are going to get included here. Whereas in this case, these extra factors won't be there. So finally, I can say in the case of bilateral transform, these extra factors won't be there. But in the case of unilateral transform, these extra factors will be there. So these ones always you have to keep in your mind. So in simple words, I can say if you go from left to right, the power of s will decrease. Whereas the derivative of the power will increase. So the derivative will increase from 0, then 1, then 2, then 10. So if you go from left side to, or if you go from left to right, the power of the s will decrease and the power of the f derivative is going to increase. So you can see here is the power of 1, here is the power of 0. Here is square, as the power of 1, as the power of 0. Here is the power of 3, as a square, as the power of 1, as the power of 0. Here is the power of 4, as the power of 3, as square, as the power of 1, as the power of 0. Only the first term is positive and remaining all are negative. Then f derivative will increase. Here first derivative, there is no derivative. If there is no derivative, then first derivative. There no derivative, first derivative, second derivative. There no derivative, the first derivative, second derivative, and third derivative. So this is what I am trying to tell you. So finally I can say, whenever you are going to apply the unilateral transform, when you go from left side to right side, the power of s will decrease. Only the first term is positive and the remaining all terms are negative, and the derivative power is going to get increases. So these points always you have to keep in your mind. So these are the formulas always you have to keep in your mind. We are going to discuss the another concept which is called as the jet transform. So basically, I've already told you Laplace transform is for the continuous time signals, and the transform is for the discrete time signals. So now let me tell the concept. So first let me tell you what is the discrete time Fourier transform. So let me tell you the discrete time Fourier transform. So suppose if the signal is f of n, then what is the discrete time Fourier transform? Which is f of omega is equal to sigma n is equal to minus m to plus m to f of n into e to the power of minus j omega n. So this is called the discrete time Fourier transform. So if sigma n is equal to minus m to plus m to mod of f of n, if it is less than infinity, means if you are going to define the value, then f of omega is going to well defined for each and every value of the omega. So here, let me tell you the concept here. I have already told you one important point, which is, say, so basically what you have learned, so basically from the continuous time Fourier transform, we have known how to get the Laplace transform also, we have understood, right? So with the help of continuous time Fourier transform, we have understood then what is the Laplace transform also, we have understood previously. But now we are going to study the discrete time Fourier transform, and then with the help of this concept, then we are going to understand the jet transform. So listen carefully. So initially we have learned about the continuous time Fourier transform, And then with the help of this concept, we have learned about the Laplace transform. Whereas in the case of discrete time Fourier transform, first we are going to study discrete time Fourier transform, and then with the help of this we are going to study the Z transform. So this is for the continuous time. So this is the, you can say this is for the continuous time domain, for continuous time domain T, and this is for the discrete time domain N. So these points always you have to keep in your mind. So these points always you have to keep in your mind. So I've already told you, for the continuous time domain, what is the Fourier transform? F of omega is equal to integration of t is equal to minus f2 plus infinity f of t into e to the power of minus j omega t into dt. So this is for the continuous time Fourier transform. Continuous time Fourier transform. Suppose if you want the discrete time Fourier transform, then what is the thing here? So then what is the discrete time Fourier transform? Let me tell the concept here. Discrete time Fourier transform is for the discrete time signal we are going to apply the Fourier transform, that is called the discrete time Fourier transform. So what is the formula? The formula is f of omega is equal to sigma, integration will become sigma here, t will become n here, n is equal to minus infinity to plus infinity, this will become f of n into e to the power of minus j, here t will become n, that's it. So therefore this is the thing. If you know continuous time Fourier transform, we can get the discrete time Fourier transform, v plus t by n, that's it. Because we are using the sigma, integration is replaced by sigma, that's it. So this is what that we are going to get. So therefore we can say, for the continuous time Fourier transform, the f of omega is equal to integration of t is equal to minus f2 plus infinity f of t into e to the power of minus j omega t into dt. Whereas for discrete time Fourier transform, the equation is here f of omega is equal to sigma, n is equal to minus f2 plus infinity f of n into e to the power of minus j omega n. So replace integration by sigma and replace t by n. That's it. So this is what that we are going to get. And I've already told you the continuous time Fourier transform is going to exist only when the absolute integration of the signal is a finite value. So I've already told you, whenever the signal is absolutely integrable, then the Fourier transform is going to exist for each and every value of the omega, or we can say it is defined for each and every value of omega. Otherwise, what is going to happen? Suppose if the signal is not absolutely integrable, suppose it is going to give a very infinite value of absolute value of the integral, then we can say sometimes the Fourier series may exist, but the problem is here, it is defined only for certain values. At certain values of omega, it is not defined. Not defined means it is going to tend to infinity. Whereas in the case of discrete time Fourier transform, so this is also going to get defined only when the absolute, or you can say sigma n is equal to minus 1 to plus root the mod of f of n, if it is absolutely integrable. If it is, we say it is absolutely summable. Whereas in the continuous time we say absolutely integrable. Here we say absolutely summable. So if this f of n is absolutely summable, then only we can say the f of omega is defined for each and every value of the omega. Otherwise what is going to happen? For certain values of omega, it is not defined. Or we can say it is not defined means its value is going to tend to infinity. So this is what I am trying to tell you. So therefore finally I can say, in this case, if the signal is absolutely integrable, then we can say the Fourier transform is going to exist and is well defined. Means at each and every value of omega, we are going to get some finite value. See, suppose if it is not absolutely integrable, the Fourier transform may exist, but at certain values of omega, it is not going to give you a finite value. It will give you infinite values. Similarly, for discrete time Fourier transform, I have already told you what is the discrete time Fourier transform formula. I have already told you here. So this is going to exist only when the signal is absolutely summable. If the signal is absolutely summable, then only the Fourier transform is exist for each and every value of omega. Otherwise, what is going to happen? So therefore, if it is not absolutely summable, then f of omega is not defined at certain values of omega, or you can say it tends to infinity. So this is the thing always you have to keep in your mind. So therefore, we can say that I have already given you right here. So if sigma n is equal to minus 7 to plus infinity, mod of f of n, if it is less than infinity means it is absolutely summable, then f of omega is well defined, means at each and every value of omega, it is well defined. So finally I can say that if the signal is absolutely summable, then the Fourier transform is going to exist, means it is defined at each and every value of omega. Suppose if it is not absolutely summable, then we can say that at certain values of omega, it is not defined. Not defined means it is going to tend to infinity. So now we have understood the discrete and Fourier transform. So now with the help of this concept, now we are going to learn for the Z transform. So suppose for the signal f of n, if you want to apply the Z transform, what is the formula? F of z is equal to sigma n is equal to minus 70 plus 30 f of n into z to the power of minus n. So this formula we have to remember. So f of z is equal to sigma n is equal to minus 70 plus 30 f of n into z to the power of minus n. So this is called as the Z transform. So let me write here. So what is the Laplace transform? I've already told you what is the Laplace transform equation. I've already told you, right? The capital F of s is nothing but integration of t is equal to minus infinity to plus infinity f of t into e to the power of minus st into dt. So this is called as a Laplace transform. Suppose if you want the Z transform. So if you want the Z transform, what is the equation? Integration will become summation. So here it will become f of z. Z transform is f of z. So integration means it will become summation. N is equal to minus f2 plus infinity. Here f of t will become f of n. And here then it will become z to the power of n. So z is nothing but you can see. So you can see z is nothing but z to the power of minus n. So minus n. So by comparing this, what we can say? Z is nothing but e to the power of s. E to the power of s. As you can see clearly, z is nothing but e to the power of s. So in place of z, if you substitute e to the power of s, then e to the power of minus n, which is nothing but e to the power of minus s n. So basically what we have did is very simple. See, let me run this part so that you can easily able to understand what I am trying to tell you. So let me run this crazy thing. So what you did basically, in place of t I have substitute n, right? So e to the power of minus s n. Then I have assumed e to the power of minus s as z and e to the power of s I have assumed z. Then it will become z to the power of minus n. That is what I am trying to tell you. So finally, if I have this part, and finally what I am going to get, then I am going to get z to the power of n. I am going to get. So z to the power of n minus n. Then what is the value of z? Z is equal to e to the power of s. E to the power of s. So this is something always you have to keep in mind. So if you know one thing, you can get the other thing in a very easy manner. So this is a Laplace transform formula, right? F of s is equal to integration of t is equal to minus into plus t f of t into e to the power of minus st into dt. So this is the Laplace transform. So if we want Z transform means what you have to do? Integration replaced by summation, t replaced by n. Here f of t means f of n. I have already told in place of t substitute n. So then e to the power of s. E to the power of s I am going to assume z. So we are going to z to the power of minus n. So this is the Z transform. So z is nothing but e to the power of s. So same thing I have written here. Same thing. So what is the value of z? Z is equal to e to the power of s. Right? Same thing, right? So z is equal to e to the power of s. So s is nothing but sigma plus j omega. S is nothing but sigma plus j omega. So therefore I have written here e to the power of sigma plus j omega. So e to the power of m plus n is nothing but e to the power of m into e to the power of n. So by this we can say e to the power of sigma into e to the power of j omega. So e to the power of sigma, I am going to assume its value is equal to r, and this is as it is, e to the power of j omega. So see basically here, this is the Z transform. So z is nothing but e to the power of s. S is nothing but sigma plus j omega. So it will become e to the power of sigma into e to the power of j omega. E to the power of sigma, I am going to assume its value is equal to r. So r into e to the power of j omega. Then what is the ROC? ROC is nothing but the amount of the Z. The amount of Z is nothing but its value is equal to r. And what is the phase angle of Z? It is equal to omega. And what is the amount of the Z? The amount of the Z is nothing but amount of r into e to the power of j omega. As amount of A into B is equal to amount of A into amount of B. So from that we can say that amount of r into amount of e to the power of j omega, as amount of e to the power of j omega is equal to 1. So therefore the amount of Z is equal to amount of r. So the amount of r is nothing but r. So mod Z is equal to r. Mod Z is equal to r you are going to get. So this is called as the ROC. In the case of the Laplace domain, what is the ROC? The real part of s. Whereas in the case of the Z transform, what is the ROC? Which is e to the power of sigma, which is nothing but r. So let me write here. So listen carefully. Here let me write here. So in the case of Laplace transform, so here let me write in the new page so that you can easily able to understand what I'm trying to tell you. So let me write here. So in the case of Laplace transform, what is the ROC? So ROC is nothing but, what is the value of ROC? In the case of Laplace transform, what is the ROC? Sorry, ROC is equal to the real part of S. The real part of S is nothing but sigma. Whereas in the case of Z transform, what is the ROC? ROC is nothing but, which is equal to e to the power of sigma. E to the power of sigma, we are going to assume its value is equal to R. So this is what you have to keep in your mind. So therefore we can say finally, in the case of Laplace transform, the ROC is nothing but the real part of S. That is nothing but it is sigma. Whereas in the case of Z transform, the ROC is nothing but e to the power of sigma, which is basically which is equal to R. So these things always you have to keep in your mind. So if you see clearly, in the case of Z transform, we are going to write in the format of the polar format, right? R and angle theta. This basically it is going to tell you about the circles. R angle theta means we can see the circles. So in the circles we are going to get in the case of the Z transform, we are going to get the circles. So now you can say, so then what is the condition for the existence of the Z transform? So which is, if sigma n is equal to minus m to plus root a mod of f of n into r to the power of minus n, if this value is going to give you a finite value, then we can say the f of z will be well defined. It is going to exist for some particular range of r, that is called as the ROC. So here then for what condition I can say that the Z transform is going to get exist means sigma n is equal to minus m to plus root a mod of f of n into r to the power of minus n. If it is less than infinity, then only the Z transform is going to get exist for some particular range of r, that is called as the ROC. So I've already told you, right? So let me here listen carefully. See, in place of S I have written sigma plus j omega. Then what I am going to get? In place of S I have written sigma plus j omega. Then what I am going to get? E to the power of minus st means I am going to get like this. E to the power of minus sigma t into e to the power of minus j omega t, right? So here if you multiply by f of t, then what you are going to get? F of t into e to the power of minus st is nothing but f of t into e to the power of minus sigma t into e to the power of minus j omega t. So if I try to find the magnitude of this value is nothing but try to find magnitude of this value. So you know the magnitude of e to the power of minus j omega t is nothing but 1. So therefore it is equal to magnitude of f of t into e to the power of minus sigma t. So you can see clearly, I have already told you in the case of Laplace transform, what is the condition? If integration of t is equal to minus infinity to plus infinity, mod of f of t into e to the power of minus sigma t, if it is less than infinity, then the Laplace transform is going to exist for a certain range of sigma, that is called as the ROC. Similarly, now let's go for the Z transform. In the case of Z transform, you know the condition, right? So what is the condition here? So here the condition is sigma n is equal to minus n to plus infinity f of n into j to the power of minus n. So now what I will do? Z is nothing but, so here let me write here f of n into j to the power of minus n. So basically, as I've already told you, what is the value of r? Z is nothing but r into, so here let me write here r into e to the power of j omega over to the power of minus n. So now here if I do simplification, what I am going to get here, it is equal to f of n into r to the power of minus n into e to the power of minus j omega n. Suppose if you try to find the magnitude of this value, which is nothing but this magnitude, and you know e to the power of minus j omega n, magnitude value is equal to 1. So therefore it is equal to magnitude of f of n into r to the power of minus n. So therefore in the case of Z transform, if integration of n is equal to minus infinity to plus infinity, mod of f of n into r to the power of minus n, if its value is less than infinity, then only the Z transform is going to get exist. Then only the Z transform is going to get exist for a certain range of r, that is called as the RAC. So what is the shortcut here? The shortcut is very simple. Replace integration by sigma. And replace t by n. Then if you replace t by n, then what you are going to get here? F of n you are going to get and e to the power of minus sigma n. And you know, e to the power of sigma is nothing but r. So r to the power of minus n, right? So you don't have to do all these crazy things, but this is the standard procedure I'm trying to tell you. So even in case you forgot, you can derive this one. But if you know the concept, just replace integration by sigma and replace t by n. So we are going to get f of n and e to the power of minus sigma n. And you know, e to the power of sigma is nothing but r. So r to the power of minus n you are going to get. So if this is going to give you finite value, then only the Z transform is going to get exist for a certain range of r. That is called as the ROC. That is called as the ROC. So therefore we can say if sigma n is equal to minus m to plus m t, mod of f of n into r to the power of minus n, if it is a finite value, then the Z transform is going to get well defined for certain range of r. That is called as the ROC. That is called as the ROC. Well defined means it is defined for each and every value. It is defined for each and every value for some particular range of r. That is called as the ROC. So this point always you have to keep in your mind. So now suppose if I want to give some relation between the discrete time Fourier transform and the Z transform, what is the relation? So what is the relation? We can say that the discrete time Fourier transform is equal to Z transform when you replace Z is equal to e to the power of j omega. In place of Z, if you substitute e to the power of j omega, then we are going to get the discrete time Fourier transform. So you can say in the place of Z, if you substitute e to the power of j omega, then you are going to get this expression, right? In place of Z, if you substitute e to the power of j omega. So what is the meaning of this one? What is the meaning of this one? You know, the general format. What is general format? Z is equal to r into e to the power of j omega. E to the power of j omega. This is the general format. If you compare what is the value you are going to get, r is equal to 1, you are going to get, right? So what is the meaning of r is equal to 1? It is a unit circle. So unit circle, it is a unit circle. So what is the meaning of this one? And r is nothing but, you know, e to the power of sigma. So e to the power of sigma is equal to 1 when sigma is equal to 0. So sigma is equal to 0 means imaginary axis. So therefore the imaginary axis, all the imaginary axis points are mapped onto the unit circle in the Z plane. So we can say all the imaginary axis points are mapped onto the unit circle on the Z plane. So therefore we can say that if you want to find the relation between the discrete Fourier transform and the Z transform, which is f of omega is equal to f of z, and then in the case of Z transform, if Z is equal to e to the power of j omega means r is equal to 1. So r is equal to 1. So if you keep Z is equal to e to the power of j omega, then we are going to get this one. So in place of Z, if you substitute e to the power of j omega, we are going to get this expression. So in the case of Z transform, if you substitute e to the power of j omega, then we are going to get the discrete Fourier transform. Same thing, let me conclude here. In the case of Laplace transform, I've already told you. In the case of Laplace transform, in the continuous time domain, I've already told you that continuous time Fourier transform is equal to, in the case of Laplace transform, if you substitute s is equal to j omega, then we are going to get the continuous time Fourier transform. Similarly, in the case of discrete time Fourier transform, which is equal to, in the case of the Z transform, substitute Z is equal to e to the power of j omega, then we are going to get the discrete time Fourier transform. So suppose in the place of Laplace transform, if you substitute s is equal to j omega, then we are going to get the continuous time Fourier transform. In the case of Z transform, if you substitute this equal to e to the power of j omega, then we are going to get the discrete time Fourier transform. So this is what I am trying to tell you. So finally, I can say that in the case of Laplace transform, if you substitute s is equal to j omega, then we are going to get the continuous time Fourier transform. In the case of Z transform, if you substitute z is equal to e to the power of j omega, then we are going to get the discrete time Fourier transform. So finally, I can say in the case of Laplace transform, if you substitute s is equal to j omega, we are going to get the continuous time Fourier transform. In the case of Z transform, if you substitute z is equal to e to the power of j omega, then we are going to get the discrete time Fourier transform. So these things always you have to keep in your mind. Now we are going to discuss the Z transform formulas. So now we are going to discuss some Z transform formulas. These are very, very important while solving the Z transform questions. So now let's see all these formulas one after the another. So for f of n, for discrete signal f of n, what is the Z transform? F of z is equal to sigma n is equal to minus m to plus m to f of n into z to the power of minus n. Just now we have discussed, right? And what is ROC? ROC is nothing but the amount of the jet is nothing but the radius r. So therefore, the amount of the jet is called as the ROC. So this point always you have to keep in your mind. So therefore, for f of n, the jet transform formula is f of jet is equal to sigma n is equal to minus n to plus n by day f of n into jet to the power of minus n. And what is the ROC? The ROC is nothing but the amount of the jet. The amount of the jet is called as the ROC. So now, let me write the points, important points only I am going to write, not everything, but you have to remember all these things. So what is the jet transform formula? F of z is equal to sigma n is equal to minus n to plus infinity f of n into z to the power of minus n. And what is the ROC? Not z is called as the ROC. ROC means only for this range of r. This is defined means it is going to give you some finite value only for this range of ROC. So now the next point is, for delta of n, what is the jet transform? Its value is equal to 1. And what is the ROC? Which is not jet all over the jet plane. Means it is defined for all points in the jet plane. So it is defined for all the points in the jet plane. So listen carefully, for delta of n. So let me write here. So for delta of n, what is the jet transform? The jet transform is nothing but 1. And what is the ROC? ROC is nothing but mod jet all over the S plane, all over the Z plane. Sorry, all over the jet plane means it is defined at each and every point in the jet plane. So mod jet is called as ROC. So it is defined all over the jet plane. So for delta of n, the jet transform is the 1. And what is the ROC? It is mod z, which is defined all over the jet plane. Means you take irrespective of the point in the jet plane, it is defined at each and every point in this jet plane. The next point is for u of n. For u of n, the jet transform is z by z minus 1. For u of n, the jet transform is z by z minus 1. And what is the ROC? The ROC is mod z greater than 1. Means if the radius is greater than 1, only for this range only it is defined, but not below the 1, but not below the unit circle. Only above the unit circle only it is defined, but not below the unit circle. So for u of n, what is the jet transform? The jet transform is z by z minus 1. And its ROC is nothing but mod z greater than 1. So, but let me give you the general formula. What is the general formula? The general formula is this one. A to the power of n into u of n. A to the power of n into u of n as the jet transform z by z minus a. And the ROC is mod z greater than mod a. A can be either positive, A can be the negative, A can be any real number, or A can be any complex number also. We'll discuss one after the other. So therefore, for u of n, what is the jet transform? Z by z minus 1, and the ROC is mod z greater than 1. So mod z greater than 1. So let me write here. Right? So for u of n, what is the jet transform? Jet transform is equal to z by z minus 1, and its ROC is nothing but mod z greater than 1. Only for the mod z greater than 1, only for this range, this jet transform is going to get defined. This only for this range it is going to get defined. It is going to give us a finite value. So now the next thing is for the other signal u of minus n minus 1. So listen carefully, u of minus n minus 1 for this jet transform is z by 1 minus z, and the ROC is mod z less than 1. Suppose if you multiply minus on both sides, then what you are going to get? Minus of u of minus n minus 1 as jet transform. So if you take minus multiply, and if you take minus in the denominator, we are going to get z by z minus 1, and the ROC is reverse of this one. Here mod z greater than 1 is here, the mod z is less than 1. So I want you to remember this one, but not this one. So I want you to remember this one. So you can say it is the opposite of this one, right? Here mod z. See, for these two functions, if you see clearly, the jet transform is same, but the functions are different and the ROC are also different. So if it is greater than 1 means here it is a lesser than 1. Both are having the opposite ROC. One is greater means the other is lesser. So this is what I am trying to tell you. So therefore you can say for u of n, what is the jet transform? Z by z minus 1, and the ROC is mod z greater than 1. And for minus u of minus n minus 1, which has z transform z by z minus 1, with ROC modulo less than 1. So for these two functions of different functions, they have the same z transform, but ROC are of different nature, means reverse nature. One is greater than 1 means the other is less than 1. So let me write this one, not this one. This is just, if you know this one, you can get this one, right? So I will write this one, which is, so you can see clearly. Let me write this formula, which is, let me write here. So minus u of minus n minus 1. So for this, the z transform is z by z minus 1, but the ROC is mod z less than 1. So this is what you have to keep in your mind. So for u of n, the z transform is z by z minus 1, and the ROC is mod z greater than 1. And for minus into u of minus n minus 1, which has z transform z by z minus 1, and but the ROC nature is different. It is greater than 1 means here less than 1. So this point always you have to keep in your mind. So now let's go for the another thing. For a to the power of n into f of n, what is the z transform? The z transform is f of z by a, and what is the ROC? ROC is replace z by a, replace z by a. So for a to the power of n into f of n, what is the z transform? Replace z by a, and here also ROC replace z by a. So let me write this point so that you can easily able to understand. So let me write here. Suppose if there is a f of n, which has the z transform f of z, it has z transform f of z. And what is the ROC? ROC is nothing but mod z. I am going to assume some condition is there. I am going to assume mod z. Suppose a to the power of n into f of n, then what is the z transform? Replace z by a. And what is the ROC? It also replace z by a. That's it. So this is what I am trying to tell you. So therefore, you can see for f of n, if the z transform is f of z, which is having the ROC mod z, and then for a to the power of n into f of n, its z transform is f of z by a, means replace z by a. It also replace z by a. So this point always you have to keep in your mind. So this is a very, very important thing. Always you have to keep in your mind. So therefore, we can say that for f of n, if z transform is f of z, which is having an ROC mod z, then for a to the power of n into f of n, which has basically it has z transform f of z by a, means for the previous case just replace z by a. So replace z by a, then we are going to get this function, and its ROC is nothing but here also replace z by a. So this is ROC that we are going to get. So this point always you have to keep in your mind. So now the next thing is, so here a can be anything. A can be either real, a can be positive, a can be negative, a can be real, or a can be complex. We can take it anything. So what is the nature of a? A can be anything. We can take a as it is we want. A can be positive, a can be negative, a can be real, or a can be complex. So this is what I am trying to tell you. So you can take any value of a. A can be either positive, a can be either negative, a can be either real, or a can be even complex also. So now, what is the next thing is? So next thing, what is the next point here? A to the power of n into u of n. So you know u of n, right? For u of n, what is the z transform? Z by z minus 1. I've already told you. And what is ROC? Mod z greater than 1. So now I am going to multiply a to the power of n. Then what is going to happen? For this, replace z by a. Then what you are going to get? Z by z minus a. And here replace z by a. We are going to get mod of z by a greater than 1 means mod z greater than mod a. So mod z greater than mod a we are going to get. A can be either positive, a can be either negative, a can be either real, or a can be even complex also. Only thing is you have to take the magnitude value only. Magnitude value only you have to take. So therefore, what is the meaning of this one? I already told you. For u of n, the z transform is z by z minus 1. And the ROC is mod z greater than 1. So therefore, for a to the power of n into u of n, here replace z by a, we are going to get z by z minus a. Here also replace z by a, we are going to get mod of z by a greater than 1 means mod z by mod a greater than 1, which is nothing but mod z greater than mod a. A can be the positive, a can be the negative, or a can be real, or a can be complex. So then you can easily get this value, right? So I don't need to further explain. Suppose now the next thing is, see, a to the power of n into minus of u of minus n minus 1. So for the signal, if I am going to multiply by a to the power of n, then what is going to happen? So for the signal, if you are going to multiply by a to the power of n, then what is going to get happen? That is what they are asking, right? So therefore we can say for the signal, if you are going to multiply by e to the power of n, then for the z transform, we have to replace z by a, then we are going to get z by z minus a, we are going to get. And here, replace z by a, we are going to get mod of z by a is less than 1 means mod z by mod a less than 1 means mod z less than mod a. So a can be either positive, a can be either negative, a can be real, or a can be complex. So here only let me write here. So here only let me write. So a can be either positive, or a can be either negative, a can be either real, or a can be either complex. So if you know these basic formulas, then you can get anything that you really require. So this is what I'm trying to tell you. So if you know these basic formulas, with the help of this formula concept, we can get these two things, right? So with the help of these basic formulas, if you apply this basic formula, you can get these two things. So you don't need to further remember all these crazy things if you remember this basic formula. So therefore, here I've already told you. So therefore, you have to remember for f of n, if the z transform is f of z, which is having an ROC mod z, then for e to the power of n into f of n, the z transform is f of z by a, means a plus z by a, and replace ROC by mod z by a. So a can be the positive, a can be the negative, or a can be real, or a can be complex. So let me write the formulas also. So these the formulas also let me write. So a to the power of n into u of n. So what is the z transform? Z by z minus a, and the ROC is mod z greater than mod a, mod z greater than mod a. And here minus a to the power of n into u of minus n minus 1, which has a z transform z by z minus a, and its ROC is mod z less than mod a. So these points always you have to keep in the mind. So now the next thing is, what is the next important thing is this one. So this is a very important thing, always you have to keep in your mind. Suppose you can say for f1 of n, the z transform is f1 of z. For f2 of n, the z transform is f2 of z. Suppose if you take the linear combination of these two discrete signals, then the z transform will also be the discrete nature of the linear combination of these two z transforms, and it is going to define only for the common range of the ROC, because if only for the common range of ROC, both f1 of z and f1 of z and f2 of z are going to get defined, then only the whole thing is also going to get defined. So this is what I am trying to tell you. So therefore we can say for f1 of z, for f1 of n, the z transform is f1 of z, which is having an ROC1, and f2 of n is having z transform f2 of z, and it is having an ROC2. So if you do the linear combination of the discrete time signals, then the z transform is also discrete time nature, the linear combination nature. But this is going to get defined when both f1 of z is defined and f2 of z is defined. These are defined only for the common range of the ROC. Only for the common range of ROC, both these things are going to get defined. If these both are going to get defined, then the linear combination is also going to get defined. So let me write this formula here. So therefore you can easily able to understand. Let me write in the new page. So here, see here. So I have already told you for f1 of n, for f1 of n, the z transform is f1 of z, which is having an ROC1. So for f2 of n, the z transform is the f2 of z, which is having an ROC2, means only for this range of ROC it is going to get defined. Suppose if you take the linear combination of these discrete signals, which is a1 into f1 of n plus a2 into f2 of n, then in the same fashion, the z transforms are also going to get defined, which is a1 into f1 of z plus a2 into f2 of z. See, then what is the ROC? The net ROC is nothing but the net ROC is the intersection of the two ROCs, or the common ROCs. Because in this common ROC, both are going to get defined. If both are defined, then the overall is also going to get defined. So whatever this ROC is nothing but it is a common ROC, or the intersection ROC of these two ROCs. Only then this one is defined, this one is defined. So overall is also defined. So this one always you have to keep in your mind. So now the next important formula that you have to remember, which is e to the power of j omega naught n into u of n. So what is the formula here? As I already told you, if you see what you are going to get, it is going to look in the format of the e to the power of n into u of n. So it is going to look in the format of the e to the power of n into u of n. So just now you have discussed that for e to the power of n into u of n, the z transform is z by z minus a, and the ROC is mod z greater than mod a. This one we have discussed, right? So what is the value of j here? A is equal to e to the power of j omega naught. So a is nothing but e to the power of j omega naught. So in place of a, replace a by e to the power of j omega naught. That's it. So therefore, what we are going to get? z by z minus a. A is nothing but e to the power of j omega naught and mod z greater than mod a. Here a is nothing but e to the power of j omega naught and mod a is nothing but mod of e to the power of j omega naught and mod of that value is nothing but 1. So therefore because of that we are going to get mod z greater than 1. So listen carefully. For a to the power of n into u of n, for a to the power of n into u of n, the z transform is z by z minus a and the R of c is mod z greater than mod a. So here a is nothing but, if you compare, what we are going to get, a is nothing but e to the power of j omega naught. So in place of a, substitute e to the power of j omega naught. So therefore we are going to get z by z minus a to the power of j omega naught and mod z greater than mod a. Here a is nothing but e to the power of j omega naught. Mod of that value is nothing but mod of e to the power of j omega naught. Its value is equal to 1. So therefore mod z is greater than 1. So this is the, for this signal, this is the z transform and this is the ROC. Means only for this range of z, this z transform is going to get defined. Now for the other signal, which is e to the power of minus j omega naught n into u of n. So for this one, what is the z transform? We need to figure out. Same thing. Here also same thing. What is the formula? A to the power of n into u of n. The z transform is z by z minus a and the ROC is mod z greater than mod a. So now here a is nothing but e to the power of minus j omega naught. So replace a by e to the power of minus j omega naught. So therefore we are going to get z by z minus a is nothing but e to the power of minus j omega naught and mod z greater than mod a. Here a is nothing but e to the power of minus j omega naught and mod of that value is nothing but 1, because e to the power of plus j theta or e to the power of minus j theta, its magnitude value is always equal to 1. So therefore its value is equal to 1. So mod z greater than 1 we are going to get. So how we got this formula? Based on the formula a to the power of n into u of n, it has z transform z by z minus a and its ROC is mod z greater than mod a. So with the help of that formula, we have got these two important things. Now with the help of these two things, now we are going to find the remaining things. How we will see here. So cos omega naught n into u of n. So I want to find what is the z transform of the signal cos omega naught n into u of n. So cos omega naught n I can write like this, which is e to the power of j omega naught n plus e to the power of minus j omega naught n by 2. So cos omega naught n I can write e to the power of j omega naught n plus e to the power of minus j omega naught n by 2. So if you keep the signal like that and if you apply the z transform, then what we can say, do the simplification of these two things. So do the simplification of these two things. Finally we are going to get this value. So z square minus z into cos omega naught by z square minus 2z cos omega naught plus 1. So this is what that we are going to get. So very simple. I don't need to further explain because it's a linear combination. So cos omega naught is nothing but e to the power of j omega naught n plus e to the power of minus j omega naught n by 2. Means add these two things and divide by 2. Then we are going to get this value we are going to get. And I've already told you, if we are doing the linear combination of the inputs, then the z transform is also linear combination of the outputs. And what is the ROC? ROC is the common ROC or the intersection of these two ROCs. So this is this one is ROC is mod z greater than 1. Here also mod z greater than 1. So what is the intersection ROC? It is nothing but mod z greater than 1. So based on this formula, so therefore we can say, so therefore what is the common ROC? The common ROC is nothing but mod z greater than 1. Similarly, sin omega naught n u of n. So if you want to find what is the sin omega naught n u of n, so if you want to find the z transform, what is the, sin omega naught n, how to write, which is e to the power of j omega naught n minus e to the power of minus j omega naught n by 2j. Then if you apply z transform, means we have to keep this one minus this one by 2j. So this one minus this one by 2j. If you simplify, we are going to get this one z into sin omega naught by z square minus 2z cos omega naught plus 1. So if you see these two things, the denominator is same. Only thing is the numerator is changed. So what is ROC? See, the input is the linear combination of the inputs. The output is the linear combination of the output. So definitely, what is the ROC? The common ROC or the intersection ROC. Then what is the common ROC here? Mod z greater than 1. Here also mod z greater than 1. So what is the common ROC? Which is mod z greater than 1. So these things always you have to keep in your mind. So with the help of these two formulas, we have got this one as well as this one. So this point always you have to keep in your mind. So now the next thing is, so with the help of this formula, now we are going to get this one. So for this one, we are going to multiply by e to the power of n. I've already told you. For f of n, if the z transform is f of z and the ROC is mod z, then e to the power of n into f of n as z transform f of z by a with an ROC, mod Z by A, means replace Z by A and replace ROC by Z by A. So here what you have to do, you have to replace Z by A, and if you simplify, finally we are going to get in this format. And here also replace Z by A, we are going to get mod of Z by A greater than 1 means mod Z by mod A greater than 1 means mod Z greater than mod A. Similarly, with the help of this signal, we are going to get this one. So here for the signal, we are going to multiply by a to the power of n. Same thing. Here also replace Z by A. Then we are going to get this thing. And here also replace Z by A. We are going to get mod of Z by A greater than 1 means mod Z by mod A greater than 1, which is mod Z greater than mod A. So this is what we are going to get. So if you remember the basic formulas, so getting this is a very piece of cake. That is what I am trying to tell you. So if you remember the basic formulas, then getting all these things is a very piece of cake. So now the next formula is same. So for f of n, the Z transform is f of z. Suppose if its ROC is mod z greater than mod b, then a to the power of n into f of n as Z transform f of z by a, and its ROC is mod z by a greater than mod b. Same thing, right? I have not done anything. Same thing I have written again. So what I have did here, for the signal, I have multiplied a to the power of n. Then what I have to do, replace z by a and replace the ROC also z by a. So that is what I am trying to tell you. Same thing I have told you, right? So same thing. Same formula I have written again, but with somewhat a condition I have written. But in this case, there I have given the general condition. But here specifically I have mentioned some condition, and with that I explain. So therefore, for f of n, if the Z transform is f of z with an ROC mod z, it may be any condition. It may be any condition. So for a to the power of n into f of n, which has Z transform f of z by a, means replace z by a, and in the case of ROC also, replace z by a. So this is what I am trying to tell you. So the concept is same, but only thing is here I give a specific condition, but in the previous case I will explain with the general format. So now the next formula is, so listen carefully, the next formula is for f of n into u of n, if the Z transform is p of z and minus f of n into u of minus n minus 1, it also has the same Z transform, but the nature of ROC is reverse. One is greater means the other is lesser. I already told you, right? So this formula you have to definitely remember. So let me write here. So this is a very, very important formula. So definitely we have to keep in your mind. So this is a very, very important formula. So definitely you have to keep in your mind. So what is the thing here? So I already told you for f of n into u of n. So let me write this point here. So listen carefully. For f of n, so f of n into u of n. Suppose if it has the Z transform p of z, let me assume, then minus of f of n into u of minus n minus 1, which has the Z transform same as it is, but only thing is the nature of the ROC is reverse. So one is the reverse of the other. So nature of ROC is reverse. One is greater than a means the other will be lesser than a. So nature of ROC is reverse. So this is what I am trying to tell you. So therefore we can see clearly here, for f of n into u of n, if the Z transform is p of z, then minus into f of n into u of minus n minus 1 as the Z transform p of z, and the nature of the ROC is reverse. So if you see, for these two different signals, the Z transform is same, but the nature of ROC is reverse, and the signal is also not same. So if you want me to give some example, so you can take this example, right? In place of f of n, I have substitute 1. In place of f of n, I have substitute 1. So u of n, which has Z transform z by z minus 1, with a ROC mod greater than 1. And here minus of u of minus n minus 1, which has the Z transform z by z minus 1, and with an ROC mod z less than 1. So you can see this condition, this formula you can apply even here also. So here f of n I have assumed 1. So both the signals have the same Z transform, but the ROC is different, reverse. Here greater than 1 means here lesser than 1. So both have the different reverse ROC. So both have the reverse ROC. And here you can say that here it is u of n means here minus of u of n minus 1 minus n minus 1. So this is a point always you have to keep in your mind. So the nature of the ROC is reverse. Oh, you can see clearly here. I have already told you for f of n into u of n, which has the z transform p of z, and for minus f of n into u of minus n minus 1, which has the z transform p of z. So both, even though signals are different, but there p of the z transform is same, but the nature of the ROC is reverse. One is greater than a means one will be lesser than a. So one is mod z greater than a means the other will be mod z less than a. So this point always you have to keep in your mind. So this is the best example, as you can see clearly from this example also you can see clearly. So now we'll go for the next point. Suppose for f of n, if the z transform is f of z, then for f of minus n, the z transform is f of z to the power of minus 1. So for f of n, if z transform is f of z, then for f of minus n, the z transform is f of z to the power of minus 1. So what is the meaning of this one? Suppose for f of n, we got the f of z. So for f of minus n, I want to find z transform is replace z by 1 by z or z to the power of minus 1. Then we are going to get certain that is nothing but this one. So therefore, for f of n, the z transform is f of z. And for f of minus n, the z transform is f of z to the power of minus 1 or 1 by z. So replace z by 1 by z or replace z by z to the power of minus 1. So this is what I am trying to tell you. So let me write this formula also. So this formula is also very much important. So that is the reason I am writing this type of formulas. So therefore you can say for f of n, if the z transform is f of z, then for f of minus n, the z transform is nothing but replace z by 1 by z or replace z by z to the power of minus 1. So we are going to get f of z to the power of minus 1. So we can say for f of n, if z transform is f of z, then for the f of minus n, the z transform is f of z to the power of minus 1 or replace z by 1 by z, you can say like that. So this is the meaning of this one. So now let's go for the another point, which is if f of z is equal to f of z to the power of minus 1, then we can say the f of n is said to be even signal. So why it is like this? Let me explain. Suppose, what is the meaning of even signal? So what is the meaning of even signal? Even signal means when f of n is equal to f of minus 1, then we can say the signal is said to be even signal, right? So for f of n, what is the z transform? F of z. And for f of minus 1, what is the z transform? F of z to the power of minus 1. If these are equal, then definitely this is also equal. So therefore we can say this is also even signal. So therefore we can say when f of n is equal to f of minus n, we say the signal is said to be even signal. Or for f of n, the z transform is f of z, and for f of minus n, the z transform is f of z to the power of minus 1. So if both are equal, then also we can say the signal is said to be, the given signal is said to be an even signal. So this is a point always you have to keep in your mind. So finally I can say that a signal is said to be even signal. A signal f of n is said to be even signal when f of n is equal to f of minus n. So for f of n, the z transform is f of z, and for f of minus n, the z transform is f of z to the power of minus 1. This replace z by 1 by z to the power of minus 1. If these two are equal, then definitely, so if these two are equal means by default these two are also equal. So therefore we can say the signal is said to be even signal. So now the next thing is, if f of z is equal to minus of f of z to the power of minus 1, then the given signal f of n is said to be odd signal. Same thing, same concept, right? Same concept that we are going to apply. Listen carefully. So what is the meaning of this one? Suppose if f of z is equal to minus of f of z to the power of minus 1. So what is the meaning of this one? So f of z, for f of z, what is the z transform f of z? So let me write the arrow in the reverse direction. So let me wrap this one. So let me wrap this one. So for f of n, z transform is f of z. And for f of z to the power of minus 1, the z transform is f of minus n. So for f of minus n, the z transform is f of z to the power of minus 1. So here there is a minus. So here also you have to keep minus. If these are equal, then these two are also equal. So the given signal is said to be odd signal. So therefore we can say a signal is said to be odd signal when f of n is equal to minus of f of minus n, or you can say f of minus n is equal to minus of f of n. You can call it anything. Same thing, concept is same. So therefore we can say that when f of z is equal to minus of f of z or z to the power of minus 1, or you can write f of z to the power of minus 1 is equal to minus of f of z, then we can say the given signal is said to be an odd signal. So this is the point always you have to keep in your mind. So even signal means f of n is equal to f of minus n. So therefore f of n is equal to f of n to the power of minus 1. R signal means f of n is equal to minus of f of minus n. So similarly f of n is equal to minus of f of n to the power of minus 1. So this is the R signal nature and this is the even signal nature. So now let's go for the other point. If f of z is not equal to f of z to the power of minus 1, if f of z is not equal to minus of f of z to the power of minus 1, so definitely we can say the given signal is neither an even signal nor an odd signal. So therefore we can say if f of z is not equal to f of z to the power of minus 1, or if f of z is not equal to minus of f to the power of f of z to the power of minus 1, then we can say the given signal is neither even signal nor odd signal. So finally I can say if f of z is not equal to f of z to the power of minus 1, or if f of z is not equal to minus of f of z to the power of minus 1, then we can say the given signal is said to be it is neither even signal nor odd signal. So what is the meaning of this one? It is f of n is not equal to f of minus n as well as f of n is not equal to minus of f of minus n. So by default we can say the given signal is neither an even signal nor the odd signal. So finally I can say if f of z is not equal to f of z to the power of minus 1, or if f of z is not equal to minus of f of z to the power of minus 1, we can say the given signal f of n is neither an even signal nor the odd signal. So what is the meaning of this one? So therefore we can say as f of n is not equal to f of minus n, or f of n is not equal to minus of f of minus n, so by default we can say the given signal is said to be neither an even signal nor an odd signal. So this point always you have to keep in your mind. So now let's go for the another important point, which is for f of n, the z transform is f of z, which is having an ROC1, I am going to assume. Then n into f of n has the z transform minus z into df of z by dz, which is having an ROC1. So same ROC is going to get present. So listen the formula here. The formula is here. Listen carefully. F of n. So f of n has z transform f of z, and n into f of n has z transform minus z into df of z by dz. So both have the same ROC. ROC will be remain same. It will never get changes. So let me write this formula here. So what is the formula? So you can see f of n. So f of n has z transform f of z. Then n into f of n has the z transform minus z into df of z by dz. So ROC is same. ROC is same in both the cases. ROC will never be changes. So this part always you have to keep in mind. So therefore we can say that for f of n, if the z transform is f of z, for n into f of n, the z transform is minus z into df of z by dz, and ROC is same in both the cases. So this is a very important formula. Definitely we have to keep in your mind. So therefore we can say for f of n, if z transform is f of z, then for n into f of n, the z transform is minus z into df of z by dz. The ROC is same in both the cases. So therefore the ROC will never get changes. So finally I can say that for f of n, if the z transform is f of z and n into f of n has z transform minus z into df of z by dz, and the ROC is same in both the cases. It will never get changes. So this point always you have to keep in your mind. So for f of n, if the z transform is f of z, then for n into f of n, the z transform is minus z into df of z by dz. So what is the meaning of this one? The meaning of this one is very simple, which is the ROC is same in both the cases. It will never get affected. So finally I can say only one important thing. For f of n, if the z transform is f of z, then n into f of n has z transform minus z into df of z by dz. So both have the same ROC. So this point always you have to keep in your mind. So now with the help of this formula, we are going to discuss some important formulas. So as you can see, for u of n, I have already told for u of n what is the z transform. I have already told which is z by z minus 1 with an ROC mod z greater than 1. Just now we have discussed, right? So now I will multiply n. For the signal I will multiply by n. Then what I have to do? Whenever for the signal if you multiply by n, what I have to do is very simple. The formula is minus z into, for this one we have to do the differentiation. So minus z into, do the differentiation of the z transform. Finally you are going to get So minus z into, do the differentiation of this one, we are going to get finally z by z minus 1 whole square. ROC is same, right? Whatever is ROC, here also same ROC. So mod z greater than 1. Suppose for this signal, again I multiply by n. Then what you have to do? For this signal, again if you are going to multiply by n, then what we have to do? Same thing, repeating. For the signal, if you are going to multiply by n means, what you have to do? Minus z into differentiation of this one. So minus z into d by dz of this function. So if we simplify, we are going to get z into z plus 1 by z minus 1 whole cube. The ROC is same, right? So with the help of this formula, the ROC will never change. Whatever this ROC, here also same ROC. So mod z greater than 1. So I hope you have understood that. So this formula you have to keep in your mind. So for f of n, if z transform is f of z, for n into f of n, the z transform is minus z into df of z by dz. And the ROC is the same. It will never get changes. It will remain as it is. So with the help of this formula only, we have got all these crazy things. So now, the next thing is for e to the power of n into u of n. So this formula we have discussed, right? So you can see for u of n, what is z transform? Z by z minus 1. What is ROC? Mod z greater than 1. So when for the signal, if you are going to multiply by e to the power of n, I have already told you, which is replace z by a. Replace z by a. So we are going to get, for this one, if you replace z by a, we are going to get z by z minus a. And here also, in the case of ROC, replace z by a, we are going to get mod of z by a greater than 1 is mod z by mod a greater than 1 is mod z greater than mod a. This is what we are going to get. Because I have already told you the formula, basic formula. What is the formula there? I have told you. For f of n, the z transform is f of z with an ROC mod z. Then for e to the power of n into f of n, the z transform is f of z by a, means replace z by a. And the ROC also replace z by a. So if you remember this formula, getting this is a very piece of cake. So now we know this, right? So for this one, suppose if I multiply by e to the power of n. So for this signal, suppose if I multiply by n, this formula I am going to apply. Then what I have to do? For the signal, if you are going to multiply by n means minus z into differentiation of this signal. And the ROC is same as it is. So minus z into differentiation of this signal, minus z into differentiation of this one. If we solve this one, we are going to get, finally, we are going to get like this. So z a by z minus a whole square. So z a by z minus a whole square. See, basically, you can do the proof. Listen carefully. First I will do one method and then I will do second method. So what I have told you, for the signal, suppose if you are going to multiply by n, what I have told you, for the signal, if you multiply by n, then minus z into differentiation of this signal. So you are going to get some solution. So what is the solution? So this is the solution that we are going to get. And the ROC is same as it is, right? So what is this ROC also? Same ROC. So this is one method. You can also do the other method. So you can see what is the signal? N into e to the power of n into u of n. But you know, n into e to the power of n into u to the power of n, you know. N into u to the power of n, you know all these things, right? So this is n into u to the power of n. So for this, what you are multiplying? E to the power of n, you are going to get multiply. So then, what is the formula? If for the signal, if you are going to multiply by e to the power of n, means replace, for this one, replace z by a, and you also replace z by a. So therefore, we are going to get this thing. Same thing for the signal, I have replaced z by a in the clay. So finally, we are going to get this one. And in the ROC also replace z by a, we are going to get this one. So mod z by a greater than 1 is mod z by mod a greater than 1 is mod z greater than mod a. So we can do in any method. If you know the formula, either you can do two methods I have told you. Either you multiply n or either you multiply in the power of n. And then you are going to get the same signal, right? Same form. So that is the reason you have to remember the formula. So if you know the formula, you can do by applying any method we can get. So I have already told you, suppose for the signal, if you are going to multiply by n, then you have to use this formula, which is minus z into differentiation of this one, and the ROC is same as it is. Suppose what I am going to do here, see, n into e to the power of n into u of n. So I will take n into u to the power of n. For this one I will take, then I will multiply e to the power of n. So if you multiply e to the power of n means replace z by z minus z by a, and here also replace z by a. So in that case also we are going to get this one. Again, for the signal, again I am multiplying by n. So for the signal, again I am multiplying by n. So again you can do it in the two methods. So for the signal, again if you are multiplying by n, then what is the same formula? This formula you have to apply. Minus z into differentiation of this signal, and the ROC is same as it is. So minus z into differentiation of this signal, we are going to get this value finally the ROC is same as it is. Or what we can do, or what we can do, I can take n to the power of n outside and n square inside. So n square into u of n, we know this one, right? For this, I am going to multiply by n to the power of n. Then what is going to happen? For the signal, I have to replace z by a. So for the signal, replace z by a. Then we are going to get, so for the signal, replace z by a, we are going to get this one. And in ROC also, replace z by a, we are going to get mod of z by a greater than 1 is mod z by mod a greater than 1 is mod z greater than mod a. So you can apply any formula that you are going to get the solution. That is the reason we have to perfectly know these formulas in order to solve this type of questions. So now the next point that you have to remember is, which is, so now listen carefully. So listen carefully. This formula already I have told you, right? This formula I have already told you. Minus a to the power of n. This formula, as I have already discussed, minus a to the power of n into u of minus n minus 1, which has the z transform z by z minus a with an ROC mod z less than mod a. As I have already told you this formula, right? So this formula I have already told you. I have already told this formula. So now see, in case if you forgot also, you can get this formula, right? So here, a to the power of n into u of n. What is the z transform z by z minus a with an ROC mod z greater than mod a. So this is nothing but minus a to the power of n into u of minus n minus 1, which are the same z transform with a reverse ROC. And mod z greater than a, mod a means here mod z less than mod a. Because I have already told the formula for f of n, if z transform is for f of n into u of n, if it has the z transform u of z, then minus f of n into u of minus n minus 1 has the same z transform u of z, but the ROC is different. ROC is reverse. I have already told you, so I want you to remember this one. So if you know this one, then how to get the remaining thing we will discuss. So for the signal, I am going to multiply by n. So for the signal, I am going to multiply by n. Then what is the meaning of this one? Minus z into differentiation of this one. So minus z into d by dz of this value. Then you are going to get this thing. So this thing that you are going to get. And whenever you are going to apply that formula, the ROC is same as it is. ROC is same as it is. So for the signal, if you are going to multiply by n, then minus z into d by dz of this z transform, and the ROC is same as it is. Suppose for the signal, suppose if you are going to again multiply by n, then what is going to happen? For the signal again, if you are going to multiply by n, then what is going to get happen? Minus z into d by dz of this one, minus z into d by dz of this one. If you solve, we are going to get this value. And the ROC is same as it is. And the ROC is same as it is, which is mod z less than mod a. With the help of this formula, ROC is same. So this is what you have to remember. So these things always you have to keep in your mind. So now let's go for the another formula. See, I've already told you.